Okay.
I started the stream, so you might as well.
All right.
刚才想上厕所，但是感觉已经没有时间去了，所以直接过来了。
Welcome to the first day of final presentations. We have 3 sessions today that we'll be doing. For guests who are here, this will be teams presenting 15 minutes about their semester, how it went, what they learned, what they did. We'll have 5 minutes for questions afterwards. We'll also be streaming. Teams, I've got the signs, the timer, so watch me. And with that, EcoVision, ready to go.
Okay, so good morning, everyone. We are Team EcoVision. We are excited and a little nervous to be the first presenter today, but we hope you'll enjoy our presentation. Here's our team. We have Jessica and Mike as our instructors and Drew as our consultant. I'm Ayaka, the producer, Shun, co-producer and tech artist, Annie, programmer. Vector, game designer, Sally and Aurora, artists and game designers. We aim to create a VR experience that teaches children about some small activities they can do in their backyard for environmental protection. Players will interact with ecosystem and witness how small everyday actions can have a positive impact on the environment. Our target audience is children aged 11 to 14, and our ideal play scene is after-school clubs. Before we go into our detailed work, let's first start with the detailed trailer video.
So for this project, our goal is to help players to recognize that small actions can improve backyard biodiversity and to motivate them to take those actions in the real world. With that in mind, we have developed 3 levels featuring a narrative with player impacts, environments with immersive visuals, and focused interactions that drive learnings, and how these deliverables advance our goal. In the narrative, players are showing thumbs and take impactful actions, showing how small efforts can heal the backyard ecosystem. To evoke empathy and curiosity, we create a rich, welcoming environment that inspires players to take care about the space they are protecting. We guide players step by step on how to perform eco actions in the games and with action chosen within chosen's ability. And here is an example on how we teach players to perform this action in real life and how they can continue learning beyond the experience.
Try this one this week again. Search for leaf litter decomposition on your human internet. It will show you the right leaves to use, like maple, beech, or ash, and which ones to avoid too, like oak leaves. They take extra long to decompose.
We designed each level based on specific and plausible action that will improve the backyard system. In the garden level, and what you see in the trailer before, the kids will know collecting certain types of leaves can supply the decomposition process. In the water petal level, we teach the kids to build and maintain a water source for wildlife. In the arbitrary bird nest level, we show how littering in the yard can be harmful for birds. All level design are finished by halves. In the later half, to speed up with production process, we progressed by doing the production, the SME interview, and playtest simultaneously. Through production circles, we improve our gameplay and the level details. After our SME pointed out the accurate information, we made adjustments to our narrative. By observations and feedbacks from the playtests, we improve our interactions, our art assets, and audio to improve our user experiences. This production workflow allowed us to max out our production efficiency while maintaining the quality. Our biggest challenge during the first half was we are not familiar enough with the production pipeline, which caused some chaos. After that, we refined our process by letting all of our members to have a clear vision about not only their own tasks, but their upstreams and downstreams as well. Our current workflow, as shown here, significantly helped us to catch up with our progress and achieve our goal. Meanwhile, we also contacted SMEs to ensure our academic accuracy. Before halves, we already confirmed the design regarding the garden level and the arbitrary bird nest level with Ms. Bozic, a natural resources specialist at U.S. Army Corps of Engineers. After halves, we discussed contents regarding the water petal level with Ms. Rhea, an extension educator about water resources at Penn State University. Both our SMEs provide us accurate and very specific information, which help us to better fulfill our educational purposes.
Over the course of development, we attend 7 playtests, including Tuesday playtest nights and the sessions with Anthony's group. While the majority of our testers were adults due to our graduate school environment, we were able to test with about 20 players in our target age group. Throughout these sessions, we focused on evaluating and refining 4 key areas. First of all, it's about narrative and story. First, we focused on are the NPCs engaging and the messages meaningful? Do players find themselves helpful or overwhelming? Second, we focused on the environment. What is the emotional tone of the world? Does it feel healing, scary, or boring? Finally, we focused on the takeaway. Do players understand key concepts like decomposition and the impact of human waste? For the narrative feedback, the kids really liked the contrast between the 2 characters. They appreciated how the squirrel acts like a mentor figure while the bird seeks help, and felt that the difference in the personalities made the story more engaging. From the faculty side, they pointed out that some of the NPC poses looked unnatural and even a bit unsettling at times, which broke immersion. Additionally, the AI-generated voices felt out of place in our nature-themed environment, making it harder for players to stay connected to the world we built. To improve the narrative experience, we made a few key changes. First, we updated the NPC animations. For example, the way they talk or walk around, to make them feel more lifelike and less robotic. We also fine-tuned how NPC moves in the scene, ensuring they maintain the appropriate distance from the player to avoid awkward or unnatural positioning. And finally, we replaced the AI-generated voices with recordings of real human voices. This helped bring more personality to our characters and made the whole experience feel much more immersive and believable.
For the environment, our SME suggested we represent some form of ongoing care for the puddle, like showing it under tree shade and keeping the water clean to prevent mosquitoes. Kids really liked the environment overall, and they showed interest in having more playful objects to explore and interact with. One idea they mentioned was paper planes, which could make the world feel more alive and fun. From the faculty, we heard that the current layout doesn't always effectively convey the sense of scale we're aiming for. In some areas, players might not fully feel that they're small within the environment. So that's something we'll be thinking about improving visually. To respond to the environment feedback, we focused on making the space feel more alive and reactive. We added more visual rewards so players can see the result of their actions, which help reinforce a sense of impact. We also rethought how interactions work at a tiny scale. For example, now some tasks like moving an object require two hands. This not only feels more realistic, but from a technical standpoint, it helps emphasize the player's small size in the world. Finally, we added more depth to the environment through scene layering and occlusion by having objects block the player's wheel or partially cover other elements. The environment feels more physically present and immersive. In terms of learning outcome, the kids found the game to be engaging, and they learned various ways to protect the environment in their own backyard. Our SME pointed out that different types of leaves compose at different rates. This insight can be used to further enhance the accuracy of the game's content. Additionally, faculty feedback suggested that it would be beneficial to find a way for kids to review and reflect on what they've learned, helping to reinforce the key message in a simple and accessible way. Based on the feedback, we added visuals, such as different types of leaves, to show that they decompose at different rates. Additionally, we have included a checklist at the end of the game to help kids review what they've learned.
So, did we achieve our transformational goal? We would like to say yes, we achieved our goal from both recognition and motivational perspectives. After finalizing our game, we sent a playthrough video to the SMEs. We asked them to confirm its academic accuracy one last time and to share their thoughts on how we designed the game to teach children about environmental protection. Ms. Ria replied with additional information and agreed that our final product is a fun way for kids to learn more about the environment. From a motivational perspective, we can also say yes, as most children showed interest in trying the activities at home. Here's a post-interview with one of the kids, where they were asked whether they would like to try the activities at home.
Like I might want to try the leaves. Garden thing. Out in our garden, which is over there. There's a window that leads to the garden. The experience of playing the game was great. It was fun and also educational. And I'm sure it'll be a great game.
What did we learn this semester? We would like to conclude by highlighting 3 key takeaways. First, establishing a clear work style and pipeline early on is essential. This was a lesson we learned during the first half of the semester. A well-defined workflow helps the team collaborate more smoothly and efficiently. Being proactive rather than waiting for a task to be assigned is important to stay aligned with project expectations. Second, it is valuable to think creatively about available resources. Leveraging what is already accessible can save both time and cost. For example, we invited people around us to serve as voice actors, which allowed us to quickly and cost-effectively produce real human voice recordings for our games. We would like to extend a special thank you to our friend Samantha and our instructor Jessica for their contributions. Lastly, preliminary evidence of impact is still meaningful. Although the semester's time frame didn't allow us to track long-term behavior changes among the children who played our game, we could say that we observed the motivation and awareness raise after they play our game. A small effort can make a big difference, and that is what exactly we aim to achieve with this project. For the next step, we are going to grant CTP, the Center for Transformational Play, a non-commercial license to use our game for research as part of their work. Thank you for listening. We are now open to questions.
Hi, yeah. Can you talk a little bit more how CTP will use the experience for their work?
We haven't discussed the detail, but they told us they will send us some form so that we can give them the
So they said that they will demo our works as an example, and also take our maybe take our thoughts to conduct further development too.
I always hate it when people don't ask questions when I give presentations, so I'm going to ask a question. You present an optimistic view of success criteria. Like you said, you optimistically say yes. I'd like to hear your most critical observation on change in behavior, because you're trying to, as I understand it, you're trying to affect real-world behavior among children who have notoriously short attention spans. So if you were to be pessimistic, where do you think you didn't achieve those goals? Like, where was the faults in data that prevent you from saying this was 100% exactly what we wanted? Like, adopt the most negative view of your most critical view of your work. One thing I'll say is when you make video games, the market is the worst critic. Like, you release a game, and you have to try to feel like what the failure scenario is and try to build around it, right? So the optimistic view is always good for investors or publishers, but the market is really different. So it's important to have both views. So I'd love to have your most critical view of this.
So we think that one point is that we build the environment based on our research on what normal backyard looks like, but the backyard looks very different for each children's home. So we cannot say if they will do that in their real home in the activities, because we don't know they have the same environment as what we built in the game.
Hi. What's the most surprising thing you learned during your project, either about taking care of the environment that you didn't know before, or about how children react when playing your game?
Well, I think so. Due to the time strain in our development, our gameplay are relatively simple, but we find that children that play testing our game really enjoys playing it, and some of them even ask to play it a second time during the playtest.
Thank you. Can you explain what the significance was of making your player reduce in size?
So first is a metaphors for like being small as a single humans to contribute to that like can help to improve the environment around use. So that's the main goal, like main like decision behind being small, and also we all think that being small and do activity in the backyard is fun. So.
That's time. Thanks, team.
Thank you so much.
Hi, good morning everyone. We are Strangers, and we are happy to be showcasing our project today. Strangers is a team of 6. We have Marsh, our 3D artist, Ivy, UI UX designer, Harry, our producer, Ryan, game designer, and Taylor, programmer, and myself as VFX artist. Mo is our instructor, and our client is Physical Intelligence Lab and the CMU. They focus on neuroscience, psychology, and how human beings learn motor skills. The playtesters on Playtester Day gave us a name, the neck game. So, what is a neck game? It's a game to play with your neck as a controller. We use a webcam and Google Media Pipe, the facial detection machine learning model, as the input of our game. Players tilt their neck to control the direction of a character and make actions with their mouth and eyes. Their mission is to keep the non-stopping character stay on the track and do the required actions before they reach the end. So if they hit the border or did the wrong gesture, they will have to restart. Here's the demo of our game, as you can see. Thank you, Taylor, for demoing. But our goal is not to deliver a game, given that our client is a research lab. So we need to balance our deliverable between a tool and a game.
So what does it mean to be a useful research tool, and what are the goals that our client really wants to reach? So above all, we need to have analyzable data for them that are generated from our game. And the data should present how well the players are doing over time and if they are doing the right thing at the right time. So for example, when the player dies, we need to know when and how and where they died and transform it into an Excel file. So with that data, they would like to observe how people are learning starting from a blank state. They want to observe if there exists a principle of learning process. And in order to observe that, they want to create simple tasks that can lead to series that can be generalized. So if people can do certain things in a simpler form, they should have the ability to handle a more complicated situation. And how do we transfer the goal into the directions that can guide our production and design? So we extracted the following restrictions that we, including our clients, consider to be the most essential point of the game. So first of all, we need to limit the visual elements so that they don't become a distraction while people are playing the game. And secondly, we need to have clear distinction between what is right and what is wrong. And then we need to have only one quest at a time and with only one correct solution. And then we need to have a configurable option and settings so that we can affect the game experience in order to generate data under different circumstances. And lastly, the game must be hard so that the players must keep practicing until they get better. And so in this process, we can have more and more data to be generated. So frankly speaking, some of these requirements are tough because they conflict to what we actually want in games. We often hope for freedom, multiple solutions, and as well as beautiful art assets. But we understand these requirements because it is under a research scenario. So it makes total sense in that case, and we want to take those restrictions into our direction. And before coming to the solution, there's one more information that was really essential to us. So where exactly will the game or the research be conducted? Basically, the game will be, actually, it has already been set up in their lab. So it is installed in on a computer, and they will invite people to come into their lab and sit in front of their desk under their observation and guidance and play our game. So this is the scenario where the game will be used. In-lab means that the player's state can be observed and in full control of the researchers, and that they will be able to label the data based on what they see. And we want to solve these problems in a manner that satisfies the need of a research, and while keeping it interesting, challenging, and attractive to whoever ends up sitting in front of the camera. And the first thing we want to solve is the visual.
And the main reason why we made this game was to meet clients' gameplay requirement. The game they tested before were only for research service and would not have enough core gameplay, not attractive enough for player. We decided to focus on gameplay, but at the same time, we still need to ensure the game remains a strong reference for research has appeal. Our approach is to work hard on game character. And we start to design a cute character. We bond joints and weights to the character. It gave the character the ability to change its movement accordingly. We made lots of cute movement. For example, floating, happy, spinning, blinking, and inhaling sadness. These actions were placed in this scenes to make the character become very lively and cute. But because our game needs to be more interactive, we need to plug in webcam and real-time visual feedback and control for the game for players. So it's because the animation we made before couldn't be used anymore. We made a new visual control system. It allowed the player to control the face of the character in the game real time. By controlling the real-time, player become more interactive within the game. And we also have different visual effects aims to give our player visual feedbacks and hints. For example, the laser is to let player know they shouldn't get close to the edge, and this all means that when player bump into a meteorite, an explosion effect will be triggered and other to show eaten successfully, bigger and smaller.
Yeah, so what are we making? So simply speaking, we're making a game that you fail a lot, but why? Because it serves our research goals. We want each player to generate sufficient data through repeat play and to help us understand their learning process and their improvements over time. So how to make the game harder? To figure out where the challenge in our game should come from, first we need to understand the core of both the game and the research. So there are two things. One, navigation, the head tilting part, and the other is facial expression, the face detection part. So let's talk about them. So for navigation, first is about player yourself. Basically, we can adjust the player's movement and turning speed relative to the level, and simply increasing player speed can dramatically raise the difficulty. And next, about the track. Here we add turns to the track, and different types of turns will produce different level of difficulty. And we have a total of 4 different turns in our game. And by combining these turns and change the turn length and the distance between these turns, we can make a curved path, and which is also a way to increase the difficulty of the game. And after done with the navigation, now comes to the facial expression. So basically, we'll ask players to learn 4 different facial expressions, including mouth open, mouth pucker, eye blink, folding lips, and use them as unique skills to handle some mechanics while navigating through the track in the level. So once we figure out about the difficulty factors, we could start planning the level progression, since we don't want the player to behave with everything all at once when they first land. So here is our first level. You can see it's just a short and simple path. It's only about navigation. And here's our second level. It's a longer and curved path. And we also add a few facial expressions in this level. And here is our final level. It's a much longer and more complex curved path. And we also introduce new and multiple facial expressions along the track. So however, we're still facing the risk of making players fail a lot. So how to reduce it? We believe it's about clarification and making the game clear. Next, we'll have Abby talk more about this.
Yeah, so aside from level design, what also makes a game hard is the difficulty of the controls. But the game shouldn't be feeling frustrated due to a lack of information and player knowing nothing about how to control. So here we need to at least provide a basic tool for players to overcome those challenges and let their skills to determine the success. So this is when a tutorial becomes necessary. And conferring with our client that we actually expect our players to start the game with a grasp of how to control, and which also improve our data collection by filtering out some accidental deaths for not knowing anything. But over instructions can backfire because we still expect our players to fail due to like slow reaction, misalignment of face expression, or any like unfamiliar with the control setting. So the goal is to give a just enough tutorial that teaches player but not too much. So we first introduce instructions based on UI-based like text, plain text. But playtest shows that it is not strong enough and it feels confusing. For example, mouth roll, this is a term from MediaPipe, and it is actually hard to imagine. We try to add like emojis to help explain, but still it is not very clear on how to perform it correctly. And to clarify the description, first, rather than mouth roll, let's say it's a folding lips, and it is an expression that you will do when you're trying not to laugh, like this. And lastly, if you're still not sure how to perform it correctly, you can just hover over to see a real human figure as a reference. Although this is the most straightforward way to help explain, but it's kind of off the art theme, so we decide not to put it outside. And to validate players' understanding, players must perform each expression to proceed in this tutorial, which also interactively confirm that player got each expression correctly. And through those layers, cues, and iterations, most players could understand how to do those control before entering into the real level design. And for our expressions, we try to select the intuitive ones which can map with the in-game action. For example, eating a planet is opening your mouth, and shooting out planet is a mouse pucker, like a kissy face. But some expressions are hard to relate, and that's when we have a playground to enforce learning for all the controls. And here you will get hints when encountering each mechanics one by one, and you won't die for not getting through the mechanics or fail to stay on track. So it's a safe playground.
So after discussing with our clients, we came up with a conclusion to give all of our game data we could support to their research. On top of that, we also give them face-related data, such as the face position, and also the angle of rotation of a player's face, and also the machine learning model readout of the face expressions and scores, which would be key evaluation factors for motor skill learning research. We also helped our clients to keep track of the player's progress and also collecting data from their moving paths. Also supply our track-related information, which enables our clients to reconstruct the player's progress from each round of gameplay. We also made this collection rate configurable, which could be controlled by our clients. We collected some data during the playtest on a naive guest, and we were able to do some analysis towards the complete rate of a certain track with the number of rounds played. And we were able to see a trend of players improving over time, which is a perfect example of learning progress from a blank state. Currently, our game runs with another server program to split up the work between the face recognition with data collection tasks and also the game itself. The reason we chose this is that our clients will host their own server to collect data and configure parameters in their future settings. Although our clients currently don't have their own server yet, we still help them to set up our game with both the game and server code in their lab.
We also provide detailed documentation and future support for our clients to ease out the process of changing parameters and also collect data they need. Now the game is set up in the lab directly, so feel free to visit their lab to play the game. To summarize, we've built a gamified research tool to observe unfamiliar motor skills learning by collecting data using a webcam, computer vision, and machine learning models for face detection. And we are now open for questions.
So it seems like the most unusual part about this is the client needs are kind of different than what we're used to. Can you talk a little bit about, was there a tension with that? Or was it very comfortable trying to find the balance between making a good game and meeting the client needs?
I just want to clarify, so are you talking about the client side if they are open with different approaches, or is on our side if we are having a hard time or we find it okay to figure out the balance?
Yeah, I mean, for you as a team, was it really straightforward? We know exactly what to do, or were you struggling to figure it out? And just how did that feel? Because it's a little different than what we've had before.
Yeah. So I think in a simpler form to answer this question, I think the process wasn't that complicated. We came up with different pitches and we pitched it to our instructor, to our client, and we figured out there were around four different approaches that we found that was solid enough that we think could address the problem, and we presented it to the client, and then the client gave feedback on each of them and tried to help us to figure out what exactly we are supposed to do. And there is on a more complicated version, it's like, well, you know, there is a story about our first semester and that the project had to shift the pivot because of the certain technology issue, and that we had to resize kind of redesign the project at the 5th week. So we didn't have that much time to reconduct everything, and both us and the client know that there is a tension of the time. So I think the process was rather smooth for both of us, and that they are happy with the thing that we make at this moment.
Maybe this is a little bit of a follow-up, but you said your data output was spreadsheets, right? And did your data coming out of the game plug easily into data sets that they're used to looking at, or did you have to create ones for the data that they were expecting? Do you understand the question I'm asking?
Can you be more specific?
Well, so we saw a lot of spreadsheets, and presumably the client, I guess the question is this standard data output that they're used to looking at and interpret, and are used to interpreting, or was the data coming out somewhat limited by what you were pulling out of the game, or determined by what you were pulling out of the game? Is that a little more?
So you mean, is there a standard of what data we should collect from the game?
Yeah.
I think we don't have really a standard for anything, but we did, I mean, before we implemented anything into the game of what data we are going to output into the CSV file, we have been showing what we can pull out from the game and hand that to the client, and the client approved what we are going to collect. And so the thing that we are outputting now, they already know what we are going to output from the game, and they do think that that's okay, yeah.
And was it like robust or enough for them? Like, this is great, and we're seeing things that, you know, we didn't expect, or like, yeah, we're getting some of what we're after?
I think they think it's sufficient, and that the game is also available to them. So if they really need any more specific details about the game in the future, they can hire people to do that.
Also, I believe they prefer raw data because they can interpret it by themselves. So that's why we just give them all we have. Yeah.
I'll continue with the data because so much is about the data. Are they also keeping the video, and is that synced well with your data, because you do have the webcam there? And you said they wanted to watch the players. Could you explain why they wanted to watch the players if they have the video plus your data log? Is there something that you get from live watching you don't get from a webcam video plus the player log?
So first, for the video part, we don't capture the video, but we do capture the mesh of your face. So basically, you can reconstruct what the player's face is doing at each, well, not each frame, but at each time that we collect the data. So you can reconstruct that. And the reason that I said you can having them observing what the players are doing, because it can handle certain cases that were unexpected. So for example, if they are not being observed, then we don't know if they keep dying because they turn their head away and that their head is out of the frame, or they just stand up and grab a bottle of water and we're not sitting in front of the computer. So by observing, they get to mark what data sets are not usable for their research or data collection. And I think that is mostly the point.
Is it important to disambiguate your test subjects' mastery of the motor skills versus them learning the level, right? Because if you know the level is coming, it gives you a level of mastery, and then that seems like it's different than motor skills. Is that worth disambiguating?
That's a great question. So we did have a conversation with our client specifically about if we should give them anything that's related to like quick reaction or like learning or memorization of a level, and they said yes, we do want to get all of those into the game, so that they want to observe all those circumstances at the same time. So I think there might be it might be ambiguous for us to tell the distinction from it, but I think they're prepared for that question and they want that to happen. So yeah.
It's time. Thanks, team.
Hi everyone, we are Spelunx. We're happy and proud to share our work on Kevin Toolkit this semester. Our advisor is Drew and our consultant is Mike. We are a team of 6 interesting people. So our goal for this semester is to make a toolkit that makes the Kevin easy to use for multiple developers with varying skill sets that can make impactful experience for Kevin. We started out as a pitch project. Now, let's review what we pitched last semester and where are we now. Here are what we expect to achieve during our pitch. And we did everything with a minor change. More than that, we did more than we expected, as these features is what we added. This is our final deliverable of our Kevin Toolkit package. It is with an interface, a custom camera, physical control inputs, audio, sample scenes, starter scenes, and tester scenes, and organized documentation. Now, how we get to there?
A user-centered tool project requires extensive user research and testing. To start, we interviewed every past team that used the Kevin to understand their pain points. As the semester continued, we also worked closely with the South Fayette High School class who is currently using our toolkit to build projects. We used playtest day as well as gems, as well as tour group demos to learn about what guests want to experience and to test our documentation as well as sample scenes. We also realized from the very start that a tool cannot be tested like a game project can through playtests, which is why we decided to hold 2 Cavern game jams this semester. These are some of the findings that we got through the playtests and jams. For the cavern space itself, we realized that immersion is the most important factor that makes a cavern experience powerful. In fact, there was in one demo where the 3 projector screens got swapped, but guests still feel very immersed in the space, and they all still wanted to take photos. We also learned that every different guest had different envisions for what the cavern can do. As for the toolkit itself, our documentation has always been well praised to be easy to follow and intuitive. And we were able to test to improve and update our features upon user feedback every time. Our most recent playtest is the second Cavern Jam. We want to thank all the Jam participants who came to, and also people who came to our showcase. In Cavern Jam 2.0, we had 13 participants who made 8 different worlds. There were cinematic experiences, performing art pieces, experimentation with UI, cooperative music puzzle game, rhythm game, horror game, and space exploration experience. This time, aside from short setup time and high confidence of developing more experiences on the cavern after the game jam, we also got feedback that our toolkit really enabled them to be more ambitious about what kinds of project they can make. And that also our documentation plays a great part in letting them understand the underlying processes of even people with lesser Unity experience. And now let's talk about our target audience.
To create a user-centered toolkit, we have to center our users. So let's talk about our target users. We want to create a toolkit that's usable by anyone who has access to a cavern and wants to build projects with it. For this semester, we focused on 2 groups. One is ETC students and faculty, and the other is a high school class at South Lafayette High School. They also have a cavern, and they're running a class about building Unity projects for the cavern space. Since our developers come from a variety of backgrounds, we wanted to make a toolkit that was simple enough for beginners to pick up, but also robust enough to support more advanced users. And this helped to shape our design goals for our toolkit throughout the semester. We decided that we wanted to create a toolkit that abstracted away most of the complexities of setting up input devices and other cavern-specific things so that people can develop in Unity as if they're just creating a normal Unity project as much as possible. So let's look at what our toolkit looks like. In Unity, this is the Unity Package Manager, and you can find our packages here. Originally, we started out with one big package that had all of the scripts in it, but then we realized that we should split out the input devices into separate packages to make this toolkit more modular and more extendable for future people who want to add and edit the toolkit. Additionally, putting our tools in the Unity Package Manager allows people to update these packages really easily and really quickly. Now let's take a look at what our packages look like in Unity. So once you download our packages, you'll see a custom toolbar pop up that says Cavern. Once you click into that toolbar, you'll see a drop-down menu that allows you access to all of these tools panels. So each panel is for each of the packages. There's a Cavern-based package that has all of the basic stuff you need for any Cavern project, as well as one for Vive trackers that includes interaction building blocks, and an Orbic one for the Orbic sensors. We also recently did a UI update to make the user interface clearer to read with icons. And all of these support a single-click setup, so you just click the Add button and you have everything that you need. Now let's dive a little bit deeper into the specific features of our toolkit. First, let's talk about rendering. In order to render a Unity scene to the cavern, which is a 270-degree screen with stereoscopic 3D projection, we had to write a custom render solution. In the past, the camera was a custom 32 camera rig. However, this posed a lot of challenges, so we decided to simplify this into a singular camera that samples from a cube map. This significantly improved the camera's performance, and our camera supports both stationary and moving camera, and also allows for head-tracked movement. Additionally, based on artist feedback, we created this mesh preview that allows you to preview what your scene will look like in the cavern on the computer. Since our first game jam, we have made several updates to this feature, including porting it over into a Unity gizmo, as well as having it live update just in this Unity scene mode, so you don't need to even enter play mode in order to see what's happening in your scene. Now let's talk a little bit more about the input devices.
So we have supported a vibe tracker such that the developers can get its position and rotation in the game. Previously, this was a huge hassle and very time-consuming to set up. By halves, we have already abstracted it such that it only takes like 2 clicks to get it into your game now. This was not easy, and we had to try many methods before finding one that works, and that required some custom engineering as well. Of course, there is no point in having a vibe tracker if you cannot do anything with it. So we've added some building blocks for interactions so that users can immediately get some basic interactions into their games without any code at all. We have follow, orbit, evade, look at, and we also allow the developers to split the cavern into different zones with a dead zone in the center, and all of these are configurable as well. And while I'm using the vibe tracker as an example for all these interactions, they are not strictly tied to the vibe tracker and can be applied to any object as well. So other than just for like vibe tracking, they are also good for general game prototyping on the cavern. Our newest addition to the input system is the Orbeck Phantom boat. So they act like the Xbox Kinect in the way that they can track your body movements. So when building our package, we had to make some considerations. Paid packages do exist on the Unity Asset Store, but due to licensing, we are not allowed to distribute them. So in the end, we decided that we will reverse engineer the open source Azure body tracking demo from Orbeck. But it came very bare bones, and there was no documentations, and there were a multitude of problems we had to solve. So this is a non-exhaustive list of things we had to solve, such as crashes if no sensors connected. And the demo was made for a single sensor, while the cavern has 3 with no native way to synchronize them. And some sensors in the cavern are mounted right side up, while some are upside down. So in the end, our solution was to support 1 sensor and 1 player in the time that we had, and we provide an intuitive interface for the developers to select which device they want to connect to, as well as to support multiple orientations for the sensors, such that no matter how they are mounted, it will not be a problem, and you'll be able to use them properly. And of course, this is how simple it is to add it to your scene. 2 clicks, we're done.
And Cavern also supports quadraphonic or 4-speaker setup, which is with a low-frequency speaker at the back. What makes Cavern audio special is that aside from post-cue of sound feedback, we can also have preview that directs audience's attention in the curve to space. To enable that, we have to have the Cavern computer configured as 7.1, and our toolkit will automatically configure the software side for our users. And sound design is most important, especially the spatial blend aspect, which is all documented in our user documentation and best practices.
Thank you. We discovered that there's 2 ways of thinking about the cavern, either as a screen or as a window. Depending on which view you're using, your user interface needs change. Because of this, our toolkit supports 3 methods of creating in-game UI. Flat world space UI is best when treating the cavern as a window, since it ignores the curvature of the cavern. On the other hand, while it can be rotated to face the center, it will always look like a flat plane. The round world space UI is our way of dealing with this. It fixes the issue by wrapping a 2D plane around the cavern so that everything faces you. This is best when treating the cavern as a screen. Both of those solutions support object occlusion and proper stereoscopic 3D. Our third option, Screen Space UI, appears always on top of everything else, and doesn't properly support 3D, but avoids the overhead of our camera rendering. This is best when creating 2D experiences or trying to render a video onto the cavern. We also noticed during our playtests that almost every cavern project needs some of the same features. For instance, everyone wants to take pictures and videos, but because of the cavern's 3D, photos look doubled. We created a modular debug menu to address this. By default, every project made using our toolkit will now have helpful information and keyboard shortcuts, such as the ability to turn off 3D, as well as quit, calibrate Vive trackers, see what trackers are in the scene, and more. Next, let's talk about our sample scenes. Up until Halves, we only had a sample scene that served as an inspirational showcase of our toolkit's capabilities. After our first jam and playtesting, we learned that users would benefit from scenes that helped them get started and get a sense of the cavern's limitations. We made starter scenes with basic features pre-configured. For example, a blank scene set up with a cavern rig configured with ETC dimensions and a single Vive tracker. We also made tester scenes that people can quickly pull up to test things like text size and color limitations or Vive tracker connectivity. Now let's talk a little more in depth about the updates we've made to our sample scene.
This is our sample scene version 2. It's mainly the player will guide the little creature to find its mom. We aim to make the players to experience a peaceful and silent experience for all ages. These are the 3 main goals for our sample scene. The first is we want to show the immersiveness of our cabin, and the second is we want to showcase the interactions. And finally, because we were having a custom camera, we try to prove the performance in our sample scene.
To achieve those goals, we designed our sample scene and now created our art assets. Here is a showcase for all of our assets. Specifically, after Halves, we update and polish our assets. We work on the look, depth, and scene and create stylized texture for it. We make sure those assets are not only look good on our PC screens, but also looking good in the cavern. Also, we designed and embedded the demo of interaction into our sample scene. We embedded the basic interactions such as mirror, look at, evade, and follow into the whole experiences. Besides that, we add more tech art features like stylized running water, wind simulation, fur and grass shader, subsurface scattering, and some VFX samples into our sample scene as well.
To ensure that our toolkit is usable and extendable, we wrote up extensive documentation, both user tutorials on how to use our toolkit and how to get set up, but also design best practices that compiles all of our experiences and experiences of people who participated in a Cavern Jam for creating Cavern experiences. We documented our code, both explaining it and within the code itself, as well as technical documentation on how we created our custom camera. Looking forward to the toolkit beyond this semester, all of our Unity packages are published and accessible. Our documentation will be hosted on a website, and there's a lot of additional features that we didn't get time for, but we would like future toolkit developers to maybe take a look at and extend our toolkit. We couldn't have made it this far without all the amazing people supporting us. We want to give a special shout out to Stacy and her class who are here with us today from South Fayette High School. Thank you so much, everyone, and we're ready for questions.
So would you say you've achieved your goal? I saw Steve nodding his head, you had jams, and you had some good comments and feedback coming out of that. So it seems successful, but where do you feel that you've achieved your goal?
If you reference like the slide in the beginning, we feel like we've definitely achieved everything that we pitched last semester and more. So we had a lot of features that we added on top of what we had originally planned. So we think that we're pretty successful in creating this toolkit.
I think also our goal was to really reduce onboarding time so people could create experiences quickly. And the fact that we were able to have so many people who had never worked in the cavern before create experiences during our game jam, I think really is a testament to the fact that we were able to achieve that.
And something that we did not expect was that we were able to host not just one, but 2 jams with it. And the first one was actually before halves. So by then, we were already able to get a lot of feedback and iterate upon the toolkit after halves.
So it was great to be able to use your stuff at a jam. The difficulty of a jam is you don't get to dive deep into the documentation. You're just trying to churn out and make what you're trying to produce. I'd like to dive in deeper to the documentation. Is it all there now? And do you actually walk through things like the tester scene and how to exercise different font sizes, as you said in your presentation? Because it'll be nice to dive in deeper into documentation now.
Yeah, so all of the user tutorial, all of the user-facing documentation is in. The Cavern technical documentation is done. Code documentation, we're still filling some stuff in the design best practices. And some of the tester scenes are very, very new. So those haven't been documented yet, but the rest of it has.
If another team was to follow up and do more work to advance the cavern, what are some of the things you'd really recommend the most?
Yeah, so part of our documentation includes stuff for future cavern teams. But on some of these additional features, we only were able to get so far with Orbeck. Creating a whole package for that from scratch is kind of a semester project on its own. But there's a few things that we think could be really interesting to look into. Post-processing for visual effects, that's something that we intended to get to but didn't have time to. Improvements for the Vive tracker, supporting more features. And there's a few things that I personally am very interested in. There's more caverns that are in the works being created, or other schools are interested in having caverns of their own, and if we are to have kind of a network of caverns around the country, we probably want some way to make projects more portable between them. And so looking into world scaling or adjusting worlds to fit the size of the cavern that they're running on, that's also an area for future work. But all of this future additional features and stuff that we haven't put on the slides is documented in like stuff that we have for future developers.
So I have 2 questions. The first question is, do you have documentation on like what breaks it? I see best practices and you're like, okay, good. Because I'm often the type of person, like when I start something, I want to say, you cannot absolutely do these things. Like do these things is probably going to fail and break. So I see the head shakes. But then the second thing I was looking for is, especially when you start getting into context of more schools, how easy is it for individual teams, like multiple teams, to work in one cavern? Like what's the pipeline of working remote, working differently, coming up, uploading? How are you addressing like that pipeline?
So I think like an example of that is our Cavern Jam, because we had multiple teams who were all working in this space at the same time. We had like a spreadsheet that like set time slots for when teams would test in the cavern, but it's really easy to like swap in and out between projects. And also for like multiple teams who want to work on a project, work on cavern projects at the same time, they can like preview what their scene will look like in the cavern within their PC, and that will like help expedite most of the like beginning processes. And then like teams can then move to the cavern and physically test in the cavern in like more developed later stages of their projects.
I think also there's a lot of, the current cavern PC crashes a lot. And so during our jam, we were always there to help people, and we know that in the future we won't be. There's only so much of that we could fix during our project. We have documented the process of taking a project and getting it up and running on the cavern, but as far as like fixing every crash that could occur, that's work that is going to be a continuing effort.
That's time. Thanks, team.
see on
have a whole slide with your face on it. Okay, well, we have to accept, did we want to increase the font over there? Or you have to do it when it's on? There's a break.
It's cooling off right now. We can't turn it back on.
I'm sorry. Well, you have 5 minutes yet. You're good.
Yeah, we'll probably be able to get it back on by the time presentation. We're trying to check the projector to see if there's something wrong.
And she was pushing buttons and she bumped the power button and it turned off. She was.
Oh, there's no confirm on the power off.
But no, the projector went dim during the first round of presentation.
Really?
Yes.
Yeah, so I don't know, if you watch a stream, you see me do this with my neck. I'm like trying to look if there's like a red light on the thing. It's still cooling off, we gotta wait. I know, but I was trying to look, I didn't see a red light, but I couldn't quite tell.
We just turned it on.
The screen got a little darker.
Yeah, we'll see it.
Hello. Sorry.
All right. Time for our next group of presentations. Haptic Waves. You ready? Got the timer?
Okay. Oh, shoot. Sorry, we're going to start again. I apologize. Hi everyone, this is Haptic Waves, and this is welcome to our final presentation. It really took a village to complete this project, and this is our team and our external programmers that we worked with this semester, and these are the faculty members and our SME who guided us through this entire semester. All right, so Haptic Waves was very exploratory to its core. We set out to learn and experiment with audio and haptic design techniques, but with a focus on low to no visuals. But this goal in itself was quite broad, so we had to narrow it down, and we narrowed it down further to 2 questions. The first one was, how do we successfully create intuitive audio and haptic design navigation game mechanics for visually able people? And the second one was, how can we craft unique experiences that communicate a story only using audio and haptics without any visuals?
So we started our research and exploration by learning about various audio and haptic design techniques. We taught ourselves about different types of sounds and frequencies and how they translate into haptic sensations. And then we progressed by trying out different types of audio, from binaural audio to spatial sound, and ultimately created a quadraphonic 6-channel setup in Reaper. The team experimented with a variety of different haptic devices, and tools like the MetaQuest controller and the bass shakers within the haptic floors worked perfectly for what we needed. We ended up with 2 different prototypes. One focused on audio navigation using the MetaQuest 3, and the other employed the haptic floor and 6-channel audio for a passive sensory experience. For our haptic and audio-driven navigation prototype, the goal was to understand how visually abled people would navigate if we took away sight and left them only with sound. We did this by translating it into an audio-driven navigation game mechanics. So, for a little bit of an experience overview, the prototype is a first-person VR game where the guest is in a room filled with invisible obstacles, trying to get from point A to destination B, relying on audio. We have 2 main mechanics, and the first one is you are following a sound that emits from destination B, similar to a beacon, and then the second one is you're sending a sound out like a probe to see if it collides with invisible obstacles. This tells them if the path they're going on is obstructed or not. One is in the space, in the world, which is making the sound, and then the other sound is made by the guest. So to do a quick walkthrough of the mechanics, so I'm going to do a really quick demo. So this is the sound of what the beacon sounds like. And the beacon kind of seems to emerge from that direction. And so now, if we were within the game, I would send out a signal to see if there's an obstacle in between me and the beacon. That's the sending signal. And then there's a receiving signal back to show us that there is an obstruction between me and the obstacle. So now I'm going to try a little bit of a different path. And so I'm sending that out, and there doesn't seem to be any response. So that would be the way I would proceed. So this is kind of how you navigate throughout this prototype and figure out by if there are different obstructions or not in the way. So for our audio design, there were 3 main pillars that we ended up focusing on after multiple rounds of testing. The first one is we wanted to make all of our prototypes, our audio sounds and sound effects really distinct so that we wouldn't confuse them, because without the visuals, we noticed that people are very highly sensitive to sound, and their brains often fill in the gaps based on different audio patterns. And so we also aimed to make sure that we avoided overstimulating people through too many layered sounds or ones that could become annoying after frequent repetition. And then we also wanted to make sure exaggerated sounds were included, because it helps fill in the space that's missing without the visuals to create more of an experience. And then for our haptic design, we built and attached several motors to microcontrollers and experimented with placing them around different sensory spots on the head and shoulders. We utilized the haptics built into the MetaQuest 3 controllers also for this prototype.
For this prototype, because it's meant to be low visual, we experimented with different levels of visual feedback to see how it would affect the way the guests navigate. At first, we started with full visual feedback. The guests can see the whole room, and the obstacle would light up for like 1 second when hit by the sound waves. It made things much easier, but quickly we realized that this wasn't really what we wanted, because our goal is to encourage the guests to rely less on vision. So in the next version, we decided to remove the obstacles from view and kept only the walls and the floor visible. Now when the guests use echolocation, they couldn't actually see the obstacles, the shape or the position at all. This forced them to really pay attention to the sound feedback. We pushed it even further by removing the walls and the floor too. Without any vision boundaries, navigation became much harder, and the guests had to fully rely on sound to understand the space around them. We did a lot of playtests throughout the process, and one common feedback from guests was about level design. They often had trouble identifying the free paths. It wasn't always clear for them to know where they were supposed to go. We had built an underwater environment by halves, but with such a complex setting, creating clear and navigable levels was a real challenge. So we decided to simplify. We went back to basic primitive shapes, just cubes and spheres like you see in the left image. Starting simple made it way easier for players to focus on navigation without getting overwhelmed. Later, we added more obstacles shown in the right image to make the challenge a little more interesting. This is where we are right now, and it's been working well based on our latest playtest. Our next step is to transform these primitive shapes into possible real-world environments, like this living room example you can see on the left, so we can start bringing these levels into actual gameplay experience. Another major feedback we got during playtest was about audio design. Since there was a completely new area for us, we struggled quite a bit to help the guests identify the direction of the sounds. We toggled between Unity's built-in spatial audio system and also experimented by coding our own custom spatial audio system. We played around with different scale parameters and tried both like linear and algorithmic methods for calculating the sound positioning. It's still something we think has a lot of room for improvement and will be a great direction for future work. Another issue that came up was that without vision, some guests couldn't even tell if they are moving or not. To fix that, we introduced the footstep sounds to give guests a more intuitive sense of where they are progressing forward or bump into obstacles. This addition worked very well in later playtests, and players gave very positive feedback on how it helped them stay oriented.
Next, we are going to talk about our second prototype, the sensory exploration prototype, which is mainly focusing on the spatial audio and haptic. Our objective is how can we craft a unique experience that communicates a story and explore different types of storytelling mediums using only audio and haptic. We built our own haptic floor, and we use only 2 bass shakers and 4 feet by 4 feet wooden platform, as well as a 4-directional speaker setup. This is what our final setup looked like. We explored the different mediums of storytelling by using existing music for the setup. We also explored stories and soundscapes to see how to effectively create an experience on this setup. We explored a full motion narrative, various soundscapes, binaural recordings, and haptic devices, including microcontrollers and the vest. We landed on the creation of a nature soundscape, and then we moved on a nature ideation to make it more complete. Earlier in this semester, we were hoping to create an experience where people can sense the nature. So our first soundscape that we created from the scratch was having a different terrain sounds, animal in the jungle sounds, including birds, frogs, as well as big cat sounds. Something we intentionally did was create a calm lead-in and then ramps with a stampede towards the end. So the purpose of that is testing different levels of immersion and also letting the guests imagine themselves in the different environment and also match the haptic feedback to the sound senses. Okay, during our soft and playtest day, we used the soundscape and we were trying to see what kind of stories the guests imagined themselves to give us a hint for future narrative design. And that turned out some guests were confused about the whole experience, and guests imagined they were in different environments such as volcano, subway, camping, and etc. We learned that we need to have a minimal context. And for haptic, although we told every guest it was a passive experience, some guests were still surprised, but they felt interesting. And guests also lay down on it and retry it by their own will. And one of the parts we did well is the spatial audio. Some guests haven't experienced that before without a headset or earphones, so that was a refreshing memory for them. And in the future, we will add a narrative.
Well, the future came, and we added a narrative. Our narrative started with a AI-guided meditation simulation pod, but glitched out and became something different, allowing our participants to experience something calming all the way through something more dramatic in some of the other soundscapes. Again, testing our levels of complexity, as well as our narrative inclusion and our haptic vibrations. Here's an example.
Hi, I'm your guided emotional mood moderation assistant, Gemma. Welcome. Please make yourself comfortable. And when you're ready, close your eyes. This is a safe space.
As you can see, a lot of the comfort and movement of the guests dealt with some of our narration, but also our great soundscape that was created. It made, for all the participants, more understandable of what they were experiencing. The haptics were vibrated in a way that they enjoyed it, but it's all subjective on what type of intensity was comfortable for people. As well as the haptic floor adding to their experience, they also said that the spatial audio was great. They were able to imagine everything that was there. What we wanted to do as a suggestion in the future is maybe add some haptics to some of the lighter moments, such as like a heartbeat, to kind of go with the experience of calmness or whatnot in the times where it's not so chaotic. Some of our constraints, some of our design considerations dealt with visualization. So allowing for them to be able to see it, we had to layer the sounds on individually. Such as also, another example is our narrative, where we had to make sure that it was enough information, spoken information, to allow them to conceive what's going on, but do more show than tell. Some of our constraints were mostly about time and technology working together. That limited us from something more interactive, as we attempted to do with our rites of passage, to something more passive, as well as limiting the amount of devices we could use to sensitize the different parts of the body.
All right, we'll quickly dive into the postmortem. Our final deliverable is a findings document where we'll talk about the discoveries we made. And a big production takeaway was communicating with external programmers. We realized we needed to be very detailed about the way we communicated our design and decisions, and also we needed to adapt quickly about the deliverable expectations we wanted from the external contractors. This was a discovery project, so we had to balance between experimenting and testing with the audience and making sure the prototypes worked. And in terms of team takeaways, we were really new to this audio and haptic space, so a lot of us were building new skills we didn't have. And to be honest, this was a great opportunity, and we were able to make complete prototypes, so it was a great big win for the team. And for the future of the project, we'd really like it if this is used as a stepping stone for ETC projects where they experiment with spatial audio and haptic design, but also for accessibility. This was not an accessibility project, but this has the potential to be, and we really want to see ETC projects have more, be more inclusive and accommodating of audiences of all types. And that's it. Thank you.
Can you talk more about, did you build any custom systems to design and paint with sound and haptics alike? What was your process? For example, are you familiar with the term ambisonics and directional sound at all, or like melding two points of sound or haptic sensation together to create like a ghost point, for example? Are you familiar with any of that?
You want to talk about the sensory project?
So not specifically, is there a question on top of that? Because I can definitely.
Well, how did you, the better question may be, what technical implementations did you do to enable your sound and haptic design?
So we experimented with different signals. The most commonly used signal was a Brownian signal because it had a lot of low resonancies and frequencies, and running them through the different filters made it cleaner for that to play through the bass shakers. And then some of the audio that we use also had lower frequencies that we were able to use, and so sometimes we channeled that through there as well.
But how did you map sound and haptics together spatially is kind of what I'm asking. Because you for example, you had 4 bass kickers on that stand that exist in space, then you have your speakers. So how did you design what speakers are triggering versus what actuators are triggering?
So most of the haptic signals we ran through the bass shaker. And then we imagined what a person would feel. And so at those different particular moments of the sound is where we played and matched it with the haptic device.
To add to Benjamin's point, the haptics weren't spatial. They were a direct feedback from the bass shakers, which was like the center point of the floor haptics, but the sound was directional in the sense that we tried to create a visual picture of like layering and introducing an element or a character in the soundscape one by one, and that is how Benjamin essentially created the soundscape.
Got it. So all 4 actuators would trigger at the same time, no matter what the experience was. Okay,
Yeah.
cool.
So if you laid out an emotion wheel, I can imagine that you did a lot with fear, that the sound of the predator and the deep sounds, you have a lot there with fear. Is there another part of that wheel, a different emotion that you can talk to about how spatial sound and haptics can maybe be a playful way for that emotion?
I would say surprise. because I would say like a lot of people didn't, even when they walked into the room, they saw 4 speakers on a wooden platform, they really never expected the floor haptic to start like giving feedback, and also they didn't realize how directional the audio was going to be, and what a relatively decent job it did in creating a picture in their mind. So a big section of it was surprise to the product itself. In terms of responding to the content, our concentration was more on making sure that we were able to get the setup working successfully and have an effective view. We didn't really work on the content or iterate that much on it. Did that answer your question?
Yeah, we were surprised and welcomed the comfort that they felt with the beginning soundscapes being more meditative, especially since we had them close their eyes. It put them in that state already. And so that emotion was also hit very well.
All right, it's time. Next team.
Thank you.
Hi, we're Holocraft Studio, a team built from an ETC faculty pitched, focused on miniature-driven virtual production. And our team, we're a team made up of Victor, who is myself, and also Leah, Jesse, Jimmy, Percy, and Boreas. Our project instructor is John, and we're lucky to have Andrew and Matthew from Disguise as our subject matter experts. And now, I'm going to present a final cut of our project, which is a mix of everything we learned throughout this semester and all the skills that we pick up along the way. So now that you've seen it, let's go behind the scenes and show you how we pull it all together. First, I'm going to do a brief introduction about what virtual production is. So basically, in a traditional virtual, and like how we decided to make it miniature driven. So in a traditional virtual production pipeline, teams work with full-scale environments and also large LED volumes and also full-size props. This setup gives live actors an immersive space to perform and also helps to create a seamless connection between the physical and virtual worlds. However, For our project, we are facing with very different conditions. First, the ETC pitched request specifically asked us to create a virtual production pipeline using the existing assets in the green screen room, also combined with the miniatures itself. So the first thing is space was one of our major limitations. The room simply couldn't accommodate full-size scenery or large sets for live actors to perform in. And also the budget was another constraint. We couldn't afford massive LED walls or a full virtual production ecosystem. So due to those challenges, we designed a new pipeline tailored to our environment. We creatively integrated miniatures, physical effects, and a TV screen as virtual background, adapting the virtual production process for limited space and resources. Our goal was to build a solution, not just to ourselves, but also for anyone in the future who might be working under similar constraints. And with all that in mind, now I'm going to talk about our studio setup. So this is the floor plane of our studio. And as you can see, the part has been breaking down into 3 parts. First is the miniature area, which we lay out all our miniature and also the screen that we're using. And the other part is the working station, which will do all the control system there, and also the mocap acting area. And also, this is how we do our lighting setup. We are using physical lights as our primary lighting resources. And now, Leah is going to talk about the shots and the decisions behind it.
So our shots are designed to highlight our skill sets. So at the beginning of the scene, we focus on showing the visual and physical environment. And once the environment is established, our main character, a rocky giant, enters the scene. So, and then we have the camera shaking and all the VFX included as the giant rolls. And we also try to do miniature puppeting and sync the VFX through projection mapping and the use of dry ice as the giant starts destroying the town. Next, we have the cannon enters the scene and fires towards the giant, where we included miniature puppeting here. And lastly, in the shot 6, we want to again demonstrate our VFX skills as the giant dies. And now, Percy will introduce the physical and virtual assets we made.
Okay, so I'll first start with the physical sets we have been used in our project. As you can see, these are the miniatures we have been used. We are using both 3D printed models with pre-purchased plastic kits together to build up the world quickly. And on the right side, it's the cannon miniature you have seen in our film earlier. And here are some painting process of the miniatures. As you can see, when those models are first assembled, they have no color, it's just gray. And on the right, it's after what I have done with it, I have painted it and also gave it with several weathering effects. And here are some more of the buildings. And this is the painting process for the cannon miniature. And the process is basically the same as what I have done on the buildings. And after that, this is the whole physical set of our world. We also use laser cut cardboards to quickly set the scene up. And also we strictly control the color scheme to ensure the virtual scene and the physical scene match. And the texture and materials on the miniatures should be distinguishable under the light settings. And later on, we adjusted the size of and the structure of the cardboard buildings to set foundation for perspective in the virtual environment, so the whole scene together can create a deep space. And now I'm going to also talk about the virtual assets and some of the VFX we have used. This is the giant model we have used in the background of the film. It is a rocky giant, so it saved us a lot of time painting the skin weight. And as for the buildings, these are modularized building pieces, so we can easily shape them into different structures. And on the right is a flag. These are all made by Jesse. And here are some virtual effects we have used. And this is what our virtual worlds look like when it all combines together.
And next, I will talk about the technical aspects of our virtual production process. And generally, our main considerations are maintaining visual logic and also integrating visual immersions.
So this is an old shot created at the playtest day by an audience. So take a look at it. What's wrong with it? The camera speed is not matched, and the building ratio is not correct. So it's really important to maintain the visual logic in virtual production. And here are some methods and techniques we use to achieve that. First of all is the camera angle. We pick the upwards looking perspective in most of our shots. On one hand, it is to create a sense of oppression from the giant. On the other hand, due to the limitation of the screen size, if we do the shot from the above, the giant will not fit in the frame. Since the scales of the foregrounds and backgrounds are different, we use a blueprint in Unreal Engine 5 to scale the virtual camera translation relative to the physical one. For the physical camera moving, we use a programmable camera slider to achieve the smooth movement of the physical camera. And this is the shot before, and this is after. It looks better and more natural, and it's really hard to tell the virtual environments from the physical one.
And in order to make a flexible and precise character control system, we created a hybrid state machine that allows the production team to switch between the, as you can see, the live mocap and the pre-made animation. The user simply press button G to switch between them. And for example, our motion capture software don't support, doesn't work well when the motion capture lie or squat on the ground. And also, if we want the giant to have some impossible or dangerous move, pre-made animations works better than the live mocap. For example, when the giant dies, we just simply use pre-made animations. The advantage of using live mocap in virtual production is that it allows for immediate visual feedback to the production team, and it also speeds up the whole creative process.
Okay, so here's how we integrated visual immersions. We've been facing a lot of problems. For example, here, the virtual smoke and the physical smoke is unsynced. They're separated into different layers. So to better improve immersiveness of the scene, we integrated various visual elements to enrich the scene. The first thing is we did the perspective match. So in a previous version, virtual buildings in the background has a subtle size differences with the physical building sets in the foreground. So we downsized the virtual building to create a perspective scaling with some exaggeration, where sizes diminishes with the distance. Here's how it looks like afterwards. And the second thing is that in the previous version, the virtual ground and the rooftops has very high reflective surfaces, leading to a mismatch between the grounds and over-shiny rooftops. So we reduced the texture roughness to solve these issues. And the third thing is that we originally had a very monochromatic crimson color scheme, and the high contrast in light and shadow is quite flat in visuals. And we fixed it.
So we also applied two dynamic ads to blend two worlds together. So we use a tool called VPT to do projection mapping, so we can adjust the fire position and project them onto the physical miniatures. Here's before and here's after, so you can see we are able to bring the liveness of the fire to the physical world. And another thing we did is to mimic the shockwave effect by using dry ice. The choice was made due to the smoke detector in the building. So it's a safer and easier way for us to do in that confined space. So one challenge we faced was that the dry ice were coming out from a single point and resulting in this strong disconnect from the digital effects. So we decided to use different cutscenes and give focus shots on the foreground. We also did miniature puppeting by knocking down miniatures buildings. The reason we have the canoe shot is that we want to show the skills to sync physical world to the virtual world. And so we include a light trigger and dry ice. We are able to mimic the smoke coming out from the cannon once it fires toward the giant. And here's a more realistic result we are able to achieve. Okay, so by considering both virtual and virtual logic and visual immersion, when we shoot the scene, we are facing different challenges and make decisions based on the space and budget limitation we have. And here's a summary table, includes everything we just talked about. And Victor will talk about the takeaways.
Yeah, so besides working on our virtual production, we think it's also very important to document all the things that we've done. So for this semester, we not only built our virtual production pipeline, but also created the full documentation package. It covers our planning, technical setups, on-set practices, and also post-production workflows. Our goal was to leave a resource for that any futures teams can build on, documenting the challenges that we faced, the solutions that we found, and the key technical notes for anyone who's looking to explore further. But overall, what do we want to improve? We aim to improve our camera tracking, mocap accuracy, hybrid integration, environmental design, and also physical effects to create a smoother, more immersive production pipeline. And through this process, we've gained a lot of valuable takeaways, which we'll like to share next. So throughout this project, we realized that balancing the physical and digital elements requires a constant real-time decisions. It's not just upfront planning. We learned how hardware limitations like latency can shape creative choices, and how critical on-set improvisation and cross-disciplinary collaboration are. And most importantly, even small adjustments can completely shift the emotional impact of a scene, reminding us how fragile yet powerful storytelling can be. And with the validation of our subject matter, we can simply says that we're comfortable and we're proud of the accomplishment that we achieved for this semester. And with the more and more importance of MR experiences, we believe that our pipeline built for real-time integration for physical and virtual elements is well suited to meet this growing demand and to scale across different MR applications. We are Holocraft Studio, a team that's dedicated to miniature-driven virtual production, and now we're opening for questions. Thank you.
This question is two-part. One is, do you think that miniature virtual production is suitable for certain scenes, more suitable for certain scenes than others? And the second part of the question is, why did you choose the scene that you chose?
Sorry, I want to clarify, by scenes, are you saying that like the shots that we established in the scene, or? Okay, so, okay, we believe that because like, what makes it different from traditional virtual production is that we don't really have a live actors that can do like acting in front of the virtual background. And so this is kind of limit the thing that we can incorporate it with the physical sets, like, which is like, they're just miniatures. Even though we can puppet it, but I don't think our craftsmanship is good enough to make that happen, at least not for this semester. So in order to create that sense of immersiveness, we believe that it is important to create that sense of skill. So the reason why we choose to build it up like this is we think that by building a miniature set of a village, of a town, that you can use like, we can build up a giant like golem or thing that creates, that attacks the town, that create that sense of horror and that sense of aggressiveness towards this town to create that scale difference. That's the reason why we choose this setup, and that's C. And yeah.
If you were going to do it again, what kind of shot sequence or scenery would placate better to the tech now that you have a semester of hindsight behind you?
I think there's a lot of things to be improved, but I'll say one of the most impactful, the most major thing that we can do is to deal with how we incorporated with the interaction with the physical sets. Because even though we now trying to use like close-up shots and with like hand pushing puppeting to create that sense of interaction with the physical sets, but still, we feel like it can be a lot better if we choreograph everything well enough and execute them with more precise miniature puppeting.
So I'm asking if you were going to make a totally different type of scenery than a city and a monster.
Oh,
is there
totally.
something else that you think would work really well for this type of setup?
Sorry. Do you mean like if we have to build up a total different scenery, what would we
Yeah,
would we
if you were going to
choose?
start totally open topic.
I. For now, I think the reason is no. I'm not sure because like it's just me like standing here like answering to the question, so I'm not like speaking for the team. But I think as a team, at the start of the semester, why we set up this to be like a giant attack on the village is because we think it can best present how to create that sense of scale difference, and that's why we choose to do this scene. So back then, we do have some different options in mind, but the reason why we choose this are because we think it better suits the skills that we have, and we can execute it better to create that sense of skill difference. So to answer that question with my personal experience, I think no. I'm not sure whether that.
You had mentioned that you thought this virtual production scheme would be suitable for mixed reality. I'm curious, do you have any design hypothesis of how you would apply it? Because I think for mixed reality, you have a lot of player agency. You know, they're walking around or interacting with the environment in some fashion. How would you apply this to a mixed reality project?
Okay, so one of the reasons that we think that it can be good for applying to mixed reality project is that during our process, there's one part that is the real-time mocap system, and we think with those kind of interactions, because what makes it different is that in traditional virtual production pipeline, we normally do the virtual background with post-processed. But through our pipeline, we're doing the mocap system real time. So also like whoever's at presence, at live, can do their acting and do that interaction with whoever's in that very scene. So. And the reason why it inspired us like this is because throughout the playtest session, even though most of the playtesters, they're not really like a film crew, so they're not really proficient at like video shooting, but still, all of them are having fun just playing around with the virtual set and how it incorporated with the digital environment with their friends being the mocap actor. So I think that kind of shows the possibility that it can bring with this project. But, okay, sure.
Sorry, I think another example for this is what Derek mentions before. He suggested that it could be used in, for Warhammer 40K, a very interactive way of playing with the chess, with the models, miniatures, and then you can have those kind of like fire projection onto the terrains that you have. So it's a more immersive environment for people to play with their friends.
Would you encourage other teams to tackle this problem, and if so, or this challenge, and if so, what might you advise them on, or?
I think we'll definitely encourage the team to explore on this, because that, even though I think like like I said, I think we're dealing with limited space and budget. That's why we're choosing to do it for virtual production. But I think with those kind of budgets, especially space, I think it's very suitable to do a more of a explorative MR experiences, just like what Jesse said. It can be like a very interactive, mixed reality gameplay, even with like 40K or like Dungeons and Dragons. I think it can be a really fun experience to explore. So yeah, and yeah.
I think this project has lots of possibility because I remember at the playtest stage, in the green screen room, everyone laughed because their friends use the mocap editor to do some stupid actions, stupid pose, and they laugh after filmed. So I still think it has a lot of possibility.
That's fine.
Thank you.
All right. Hello, everyone. We are Team Wizard Mode, and this is the final presentation for Full Tilt, which is the title of our project. Here is the team, Jasmine, YC, Magna, William, Cynthia, and Sky. And our client is ETC K-12 with John and Anthony. Our consultant is Jonathan, and we also wanted to give a special thanks to Dave Perda for all the help and guidance that he gave during the entire project. So ETC K-12 tasked us with creating a multiplayer pinball experience that combines physical and digital components for the audience of multi-generational families. And the ultimate goal of the project is to create a high-fidelity prototype that encourages play among families. And this prototype will later be modified and then be installed in Pittsburgh. And for a little taste of our project, here is a short trailer.
Cool. So this is our earlier design diagram. It looks really similar with what you see in the video, but we did went through multiple iterations, especially come to the layouts of the buttons and the plunger based on the feedback we got from playtest sessions and self-openings. And this is another close-up look at our final setup. We want to support, up to 4-player multiplayer, while also single-player experience, and also have the flexibility to further adjust to the needs of our clients. And we want to introduce the game without a dedicated onboarding page. So we decided to add some really simple instruction tech, and also as long as the graphic illustrations of the controllers to draw more connection and have more clear communication how the game works, especially the controller to the player, and let them jump in easily. And throughout the semester, one of the key custom control that we built is these 2 sets of plungers. By using the supersonic sensor from the Arduino kit, we're able to measure how far the player pulled the plunger and recreate the haptic feedback when we actually launch a pinball in the actual machine and bridging the physical and digital world together. And another big thing to their product, especially come down to fabricating the physical components. Excuse me. And this is how our plunger and light switching mechanism work in action. We want to add another layer of excitement, especially launching the ball. So we added LED light strip that corresponding to the ball color in the scene to draw more connection between the gameplay and the player. Next, we'll have YC to go over some of the contents of the playfield.
All right, on the iterations of the playfield itself, this is the version we had for halves. Then we got feedback from people that are saying this doesn't quite feel pinball enough. As a result, our project consultant Jonathan took us on a field trip to a pinball arcade here in Pittsburgh named Pinball Perfection, where we got to see some pretty cool pinball machines from the 60s and 70s and learn from their playfield design. Namely, our final version of the playfield now have these lane dividers on top of the playfield to control through which lanes the pinballs enter the playfield. And we also decided to move the outer set of flippers to the bottom. The idea is that this way, the outer set of flippers and the inner set get more or less the same amount of action because after the ball launches, it most likely goes to the inner set of flippers first, while the returning tracks always return the balls to the outer set of flippers. In terms of gameplay, we originally wanted an undefined experience with no explicit goal that just lets the player decide what they want to do with the games themselves, which is what our client wanted in the first place as well. However, as the vast majority of players who playtested our project wanted a goal of some sort to know what they're doing or feeling like they were achieving something, so the middle ground solution we found was to first have a score system that rewards certain actions like feeding the gobbler in the upper left or switching the theme. And we also hide achievements in-game that pop up whenever you've accomplished them. The idea is that we are providing the players with some guidance while preserving the free experience that ourselves and our clients wanted in the first place. Next, we have Cynthia going over our art process.
Thank you. When we developed the themes, we aimed to create boards that feel visually connected but still unique from each other. Ultimately, we have 3 different things that each of it was inspired by a popular cultural aesthetic from the past 30 years. Y2K, footage era, and vaporwave. These styles all fall under the nostalgic trends that reflect how we used to engage with media and technology. Since the pinball was also the most popular in that time period, we believe these aesthetics are a great fit for our game. The first thing is inspired by Y2K culture, which appeared in the late 90s and the early 2000s. Named after the year 2000 problem, we decided to recreate the components referencing some retro tech devices in a pixel art style, such as Tamagotchi, Sony Eyeball Dog, and Game Boy controller. Moving to 2004, footage era followed the Y2K aesthetics. It features the bright, glossy visuals, just like the classic Windows icons. And as you can see, the bubbles, grass, cloudy sky, and tropical fish, all these elements in a very clean and vibrant color palette. Lastly, we have the vaporwave, an aesthetic that became popular in the 2010s based on the vaporwave music genre. Its visual overlaps a little bit from the previous 2 aesthetics, and for this playfield, we highlight the neon colors and the surreal spatial feeling that vaporwave is usually known for. Next, let me talk about our iterative process. These were our plan at the halves. At that point, we wanted to create the dynamic playfield, implement the sound, building the physical components, and also get the test with the multiplayer. And this is what we completed by the playtest day. We created 3 dynamic playfields, tested with the multiplayer and families, which were our target audience. And also we created a custom board with a reinforced plunger. And now let me introduce Jasmine to share more about it.
Sure, so the playtest went well. We love the kids love our game, so the parents love us.
Well, so what we've observed from the players is that the younger players, the kids, they just love smashing the buttons. And they're very excited to see the theme changing with the vivid colors and the animals in our playfield. Also, they would just play the game nonstop until us telling them it's the time to finish the playtest session. Compared to the kids, the parents, the older group, is actually who were really growing up with real pinball machines. So they were more acceptable to our new take of making the digital pinball game here. Also, the parents, because of their age group, they're actually very familiar with the themes we choose, like the Y2K footage arrow and the vaporwave is their thing. So they could even recognize some of the art assets in our playfield as well. Also, the reinforced physical plunger got many positive feedbacks from the parents. Most importantly, all group played our game collaboratively without us even telling them to do so, which is exactly what we and our client want. However, there are some aspects we need to improve for sure. Players ask for more visuals and sound feedbacks. And we're very clear that the pinball game is all about the sound feedbacks, like the flipper sound, like the plunger sound. So we immediately implement the whole feedback systems of visual effects and sound right after the playtest day. Also, players said the game felt a bit endless, like it takes too long. So we add a timer of 5 minutes to limit one play session. Last but not least, the player asked for goals. To solve this, we have a very simple achievement systems right after, showing on the picture on the left side. We just tell the player to hit certain amount of bumpers or have like certain numbers of pinballs in the playfield. Also, we built a very cool thing, the LED light strip that indicates the color of the pinball in the current plunger. So next, let's have Sky talks more about these components and how we iterate them after softs.
Thank you. At softs, we presented a version of our project with the previously mentioned changes. Now, within the feedback we received, the issue of the players having a difficult time understanding the goals of our game came back to us. Specifically, the majority of the feedback we received revolved around two potential solutions. One is to include a score system, and two is to expand upon the onboarding portion of our game. As the team discussed ways we can better inform players about the goals of our game, we realized that a dedicated onboarding segment could come in conflict with our intention of having the players discover the mechanisms of our game as they play, and then coming up with their own goals. And so after a meeting with our instructor and our clients, we decided to, for the most part, maintain the discovery aspect of our game while focusing the majority of our efforts on amplifying the visual and audio feedback in order to facilitate the discovery process. And at the same time, we want to keep the onboarding elements to a minimum. And so in the end, what we did for onboarding was we included text elements in the mock-up of a housing unit that we built for our hardware parts. This way, players who are less familiar with pinball can kickstart their experience. In terms of amplified visual and audio feedback, we finished coding and installing the LED light strips to correspond to players switching of the color of the ball, as well as launching the ball. We hope this visual emphasis on this action would incentivize players to switch between different colors of the ball, which is a prerequisite for them to activate the 3 different themes. On the digital side, we implemented a score system, adding another layer of visual feedback to player actions. We also furnished our achievement system with 12 achievements. They show in this grid at the end of the 5-minute experience with the completed achievements lit up. We're hoping this way it would give players a sense of a proper experience, as well as point them to some things they can focus on a potential second playthrough. And finally, Meghna will talk about our takeaways and our next steps.
Okay, awesome. So what is the future of Full Tilt? So our deliverables for this project is that we're delivering a digital pinball experience that's fully furnished, along with physical plunger controls that are reinforced, so that way they can withstand multiple hours of play. Additionally, we also added reactive LEDs that react to the ball being launched, as well as the color of the ball changing. And then we're also building it so it can be flexible and portable. Some parts can actually be replaced. For example, while we had a physical board in our experience currently, it could potentially be replaced with a projector screen. And then finally, we're also documenting the entire process and then passing it over to ETC K through 12. And the next steps for ETC K through 12 is that they'll be taking this build to play test at the Children's Museum on May 10th. And in terms of what we learned from this project, it was pretty interesting because not only were we revamping an old school game, but for a lot of us, it was our first LBE project dealing with physical components. So we learned a lot of valuable skills in building physical components, specifically with Arduino. But I think one of the most important lessons that we learned from this project was how to play test for design goals. I think one thing that we kind of got stuck on very early on was that while we were play testing, we were mainly play testing to see if players had fun, which obviously they will, it's pinball. But we weren't really testing for design goals, just seeing if it was just fun. So in the later half of the semester, we really aimed to fix this through our playtest utilizing achievements and designing around creating a scoring system and these design decisions around keeping the element of discovery while also still having goals for players to sort of achieve. And thank you so much for listening to our presentation. We'll now accept questions.
I think your takeaway about playtest goals is really important. You'll be surprised that even like very experienced teams really struggle with that. So it's something you should remember for like the rest of your career. The main question I worked on a game called Peggle. And I'm curious whether you thought about tuning your physics system. So one of the things that Peggle does as a design goal is it makes the player feel lucky. Which is very hard to do. I worked at a studio that tried to rip off PopCap games, and they never tuned the physics system, so they never could make their game the player feel lucky. And one of the things you have, which real pinball does not have, is the ability to play God with physics. It's a lot of work, but I'm curious if you thought about that, because if you subtly change physics in lots of special cases, you can drive lots of, I think, a sense of skill, which pinball is really hard because it's very skill driven. So and tilt is how players can make a pinball board feel different, right? How you can physically move the pinball machine without actually having it go tilt. That's sort of the version of tuning physics in the real world. I'm curious if you thought about tuning physics, and if you were given the opportunity, what would you do?
Yeah, for sure. So actually, because this game is developed in Unity, so we have the ability to adjust, or tuning the physics, all the the gravity and stuff. So we intentionally make it easier for kids. So for example, in this game, the gravity is actually bigger than what we have in the real pinball machine. So the pinball falls faster, but when it hits the flippers, the collision volume is actually bigger than what we look with our eyes. So we make the collider bigger, so the kids, even if they slightly fell off with hitting the buttons, they will still catch the ball. That's one thing. And secondly, when we are designing the achievement systems, we also kind of intentionally make, I would say, majority of the achievement very easy to get. So it's like you'll get achievement every 10 seconds you play the game. So you get the feedback really quickly. And also seeing those VFX, visual feedback effects, and also hearing the sound, we adjust the speed when the sound or the particle effects emit. So we kind of want to make the whole experience synchronously. You see what you hear, and you smash the button, you hear the sound, you see the VFX, and that's what we think we want the kids and the parents to feel. This game is not only in a digital world, but also it will be affect in your real actions. Yeah.
And also the point is for our core mechanism, we said like the plunger can plunge like endless balls. So for the co-op game, the multiplayers, they won't like be blame each other like you lose the ball because you can keep launching it. So it's also another point.
Was there any inclination to try other inputs besides a plunger and flippers, add some sort of rotary or, anything else?
I think the other thing that we wanted to try was having physical flippers. And we did have the parts ordered, but they never came in, so.
Why did you want to do physical flippers?
Partially because we actually seen examples online of people being able to achieve physical flippers, and that way it would give the haptic feedback of like how the flippers move and that sound, and being able to see that visually on the screen. This was also when in the phase of the project when we were still doing projection mapping, so it would add another element to our projection mapping of being able to move. But I think ultimately we kind of focused our efforts more on the plungers, and then that way we were able to be able to kind of customize the plungers more to be able to fit with that haptic feedback, and kind of give that same haptic feedback that flippers would have gave.
I'm only thinking about this because the juxtaposition of your presentation and family activities, and recently I was at Topgolf with my kids, which I'm horrible at. But the flippers and the whole idea of people, I think, could be a unique opportunity to treat them as customizable, similar like a driver. So if you have one that is lightweight, they can go fast, one that's big and heavy, it can hit a different way, and that produces this kind of reward system of the type of player, like the kids who like to mash really hard versus the intentional hit. But I'm just saying that out there because this kind of multi-generational family activity, I'm curious to know a little bit more about your playtesting and looking at other types of, like, did you look at people who go to Dave & Buster's and look at these types of families coming together to game, which the dynamic is completely different than like the individual. Talk more about like what you saw with like family dynamics.
Yeah, of course. So during playtest days specifically, we did have families that came up and told us like, oh, we actually have like a pinball machine in our house. We're really like into pinball, and these are the things that I feel like are missing from the game. And in terms of like those dynamics, I think for definitely like the families that have younger children, they tended to sort of lean towards what the younger kids wanted to do. And then those that had older kids, who were the ones that were kind of more pinball enthusiasts, they tended to be more focused on trying to figure out what the goal of the game was, which is when we sort of realized, like, okay, we need an actual goal for our experience, and we need an actual score, because especially for those families who are a little bit older, because I think this particular family was like, was 3 adults, so it's like the parents and the kid. And so that was when we kind of realized we actually need a score, especially for those like enthusiasts who are really into pinball and want to be able to kind of understand like where they are in the experience.
Just a quick question. This intersection of digital and physical space, aside from the project you built, are any of you interested in exploring this space further for other applications, physical and digital world coming together?
I think definitely for me.
Same for me.
Yeah, yeah.
So I only wonder what the difference is psychologically. I want to make and I'm with this. It's different because I'm straining and I'm having to compensate for different things. But this is hard. I'm willful. I'm keeping my hands already. And then on top of that, what does it mean to search for sounds? So there's some weird sounds in my head, and I don't know. I asked my wife, basically sounds like a large door. We can figure out whether that's like swinging, or is it someone's door, or someone's swing, or some branch. It's the eerie sound, and I find myself like, I would like to see the pain bothers me, because that's a whole other thing about when you have your eyes, when there's great sound, and you're trying to identify what it is. Like that's also a phenomenal thing, and you are touching all of that, which I think is like
your mind does Yeah, my research took me into
Did you see my notes that I didn't have access to my presentation at first, so I just kept sending emails. Oh yeah, I shared it. I mean, as long as we can still rehearse. Oh, you need that? No. Great.
And the laser? I mean, pointer?
Cut out the video anyway.
So we'll just have to, yeah, everything stays fine. I'll just have to add the video.
start with the mic.
Oh yeah, Sarah will pass it to Faye. Wait.
And you will pass it to me. Yeah.
Sarah wouldn't pass it to me. Like she's done first. While I'm talking, she'll give it to you.
Oh, yeah. One person at a time or two people?
One.
One. Okay.
Yeah, it doesn't. We're standing just like that.
Yeah. So you need
That's
to
awkward. Okay.
And then you pass it to me.
I'll pass it to. Oh wait,
You to
I
Jim.
don't pass it. Yeah.
You pass it to Jim.
You pass it to Jasmine.
Yeah, I pass it to Jasmine.
Sorry, who passed?
They pass it to you.
Okay.
And then,
Yeah.
yeah.
Okay. That's simple.
Yeah. Pretty much. Our final.
How about little hats?
Oh, hats. Tomorrow. What's our dress code? Oh, blue, navy, and the hat.
Yeah.
But it was just like this.
And make sure you find your light. Probably a little bit in the way, but you know, usually just follow your inhibitions and pretend there's no one in the room. Or it's an audience full of people waiting to hear her lead. So go ahead. You can do this. Yes.
Yeah. So I'll be here. It goes me and then so we go to opposite sides.
Do you want
And
me
then
to
Faye's
time
on
it?
my side.
Since we don't have to clock, or do you want to set, I can time it for you.
Yeah. Give the mic to Jay. Yep. So then Jasmine, you're on that side. Well, then you have to get it back. Who do you get it back from? It goes Jim and then.
Oh, that's bad.
Wait, then you should both have a mic at the same time. So then
No,
at the end.
Anna's speaking before Jane, and Jasmine is basically faded.
Okay. So it works perfectly. Never mind, it's not bad. Okay.
Okay, are you ready?
Nice, people left. Yes. Okay. Hi, we are Team Encore. My name is Sarah. These are my teammates, Jasmine, Anna, Devika, Faye, and Jim. We have our faculty advisor, Cheryl, and our client/collaborators, TJ, Lillian, and Madeline. So for our project, we created an interactive exhibit in the Purnell lobby to immerse the guests and prepare them for Titanic the musical. To do this, we used lighting, audio, and interactive set pieces, and we highlighted the themes of hope, dreams, inequality, and fate that the musical focuses on. Yeah, you guys. So for our target audience, we
我不想看，我想闭麦。我们一个问题回答5分钟。
哦，他应该可以的，我觉得。
这个给我一下。
这边有一个，你们俩过来一起。
那我得跟他站。这个收音能收好远，这个收好远的。
我操！没太可见过。
还有这个东西。可以，我们把我们东西，番茄块东西站起来，你站那边。哦。Hello。
Good luck. All the best. Thanks.
带上我的小抄。
对，没有办法讲。
对。Q&A 让他们在这边，这样他就不会问我。
这个小抄看着舒服。
20。Then. Yeah. Should we just...
All right. We're going to get started here. Welcome to the afternoon with final presentations. We have 5 teams. This actually is a slot. Starting with 10 particular slabs. We're also streaming, I believe. Teams have 15 minutes, then 5 minutes for questions. I'll keep track of your time to watch me. But with that, whenever you're ready.
Thank you. Okay, hi people and also people online. We're Team Lenticulous Lab. Oh, it's not on. Which one? Oh, okay. Oh, sorry about that. Okay, and then this is our final presentation, and we're working on a project called Cat Dash. And this is our team photo. I'm the producer of the team. Cassie is our UX designer, and we're doing co-production. Lydia is our game designer. Richie is our artist. And Jimmy is our tech art, and Oscar is our programmer. And we have Derek Ham as our project instructor. Okay, let me talk about our project. Cat Dash is a fast-paced minigame on the looking glass display, which is a screen enables 3D viewing without goggles. And in our game, player can play as a speedy cat courier dashing across the rooftop to deliver food on time. So in order to play this game, you need to tilt your head to pick around the buildings and discover the hidden passes to make the perfect delivery. I'll hand it over to Jimmy to talk about the demo video.
Thank you. So I'll walk through the demo video of our game, Cat Dash. So on the left is the first-person view, and on the right is the third-person view. So initially, the player will start as a cat courier, whose mission is to pick up food orders across the buildings and deliver them to the destination on time. Each building has its own height preset, and that is how we turn the idea of depth on the looking glass display into a gameplay feature, the height difference. The player must carefully observe the surrounding buildings and manually control the cat to jump between rooftops whose height difference is within a safe range, otherwise he will die. And that observation can only be made by moving their heads to the left or right side of the looking glass. Based on this idea, the player will have to collect food orders and navigate through the city to deliver to the customer's place as soon as possible for higher tips. In order to add more challenges, we also introduced some new features, such as the magical buttons that can transform building heights. The player can step on these buttons to change the height of the other buildings. This can unlock more possibilities to crack the game. We also generated different city landscapes, and the difficulty of the levels will increase gradually based on a friendly learning curve. And the player can challenge themselves by delivering faster and faster to avoid the customers complaining. So in short, every detail was crafted to bring out the depth and richness of our gameplay experience. And now Esther will keep talking about our development timeline.
Okay, thank you. And I'll walk you guys through the development timeline. And I would like to divide this whole semester into two bigger parts, which is before GDC and after GDC. And also, at the very beginning of this semester, we have decided that we're going to do smaller projects, since our semester goal is to do the technical exploration. And we completed 3 prototypes throughout the semester. So during our pre-production phase, we finished our first prototype, Flying Egg prototype, and this was a really good chance for us to get familiar with the looking glass display. And move on to the second sprint before HAPS, we did our second prototype, which is Orbit. In this experience, we better integrated the depths of the screen to the game. And as for the GDC, it was like super hectic, so we spent our time finalize the Orbit game prototype and get more feedback. Moving on to the second half of this semester, we were facing a challenge to whether keep developing the Orbit or start a new prototype. And we decided to start a new one, which is the Cat Dash. And we believe that it is the better solutions to integrate the depths into the game. And we spent our last sprint from weeks 13 to 15 to finalize it, improving it, and polishing it. And I'm going to hand it over to Esther to talk about more technical details.
Thank you, Esther. So, looking back on the semester, it is not just a technical exploration on what the heck can we do on this 3D display screen that renders 80 cameras at the same time. But really, there's an undertone to finding the meaning for that. Like, from why are we using the screen to what are the meaningful experiences that we can bring on the screen? It's a really important question because it kind of comes down to what we do. And when we align our visions on making small games onto it, there was a really simple reason for that. It's because that's what we do. Like AI, like any other technology out there, this looking glass is like a mirror. It reflects what we do, who we are, and what we really enjoyed is making games and playing games, and that's why we decided to make some small gaming experiences on there to explore the full potential of this device. So moving on to our first iteration, which is our first prototype, we had no idea what can we do with this thing, so we just kind of go ham. We kind of went out of our ways to see what we can do with it, to try to break it. And in fact, we did break it. We tried physics simulation on it, and turns out rendering 80 cameras along with physics simulation was not the core gameplay that we wanted because eggs keep falling out of the pan, things got messed up. So we learned from our experience and really confirmed on the fact that, yes, we do want to keep breaking this thing and keep seeing what we can build with it. So moving along with that, we got to Orbit. So Orbit was somewhere that we built this game that is basically an infinite runner along with Goldminer. It was like some of the older games, and try to use a sense of depth to bring the player, to bring either our guest or our player forward into that motion and kind of show them all the really interesting thing, the really intriguing thing of using the depth. However, it introduced some issues. So first of all, we learned a lot of things. And to conclude that, first of all, we learned that we need to play nice. By playing nice, it means play nice with a feature that we already have. Because there was a limitation, the technical limitation that we noticed was this focal plane, that if you shift things too far away with it, everything gets rendered really blurry. It wasn't great. We tried to essentially fit everything onto that plane. But running through a tunnel doesn't really work that well. So we had to scale it constantly, to rotate it constantly, to get everything to fit on there, and that took us a lot of time. And sometimes solving every technical issue wasn't really the thing to do, especially here. We had time limitations. And that kind of brings us to a thing that we kind of missed on this project, which is to answer the question of what is really depth playing in this experience. We did try to bring the player to form a motion and really show them the intriguing part about it. However, we didn't put any meaning or gameplay meaning into the depth. For example, the player is just kind of moving along the line, and they don't have agency, nor that they can read any information that could be helpful along their journey to try to use it into the gameplay. So learning from that experience, we did make a lot of changes, and in the end, we decided to make a new prototype called Cat Dash. And let's have Lydia talk about some journeys that we've gone through.
Okay, so before we went into Cat Dash, let's take a look again on our project requirement. First, we definitely want to use 3D dev because it's a 3D screen. And how are we going to use it? We want the player to observe the screen from different angles. And also, one thing that we learned from the previous prototype is that we are building a game that is workable on the screen, but not only for it. So I think if a game is also playable on a normal screen, then why people are going to buy Looking Glass, why people are using it. So we have our third requirement kind of like hidden here, that is a game not playable on a normal screen. With that in mind, we have our birth of Cat Dash. It's a strategy puzzle game, and the idea originally came from standing on the top of a building and look down. And now imagine the height being the depth in this scenario on the screen. So we do have our first key feature is to let the player distinguish the height difference between the buildings when you are kind of like looking down on the screen, like the bottom right picture showing that. And then also, how do you distinguish the difference? Of course, by observing the screen from left and right. So we have our very rough original prototype right here because we shifted after half. On the left side, you can see that without height, it's just a normal 2D grid. But on the right side, although it's very blurry, you can still see that some of the grids looks more pop out than others. So with so many polish, we have our now playable version. On the left side, that's how Cat Dash look on a normal screen, a normal computer display. You can see it's a kind of like 2D action game that is without 3D volume. And then on the right side is how you will see it on the Looking Glass display. As the camera moving from the left to right, you can tell by the shadows and then also visual that there is a high difference between those grids. And that's our game, Cat Dash. Now let's talk about some playtest takeaways.
So we did some playtests during the semester to improve our game experience, and then we have 4 major takeaways. First, we need to clarify the relationship between the timers and the tips, because we've noticed that a lot of players have a hard time associating getting to the destination faster with earning more tips, which means that we need either punishment or feedbacks if the players couldn't finish the task before the time's up. And then secondly, because of the blurry nature of the Looking Glass display, sometimes the height differences are a bit hard to discern. So we need a clear indicator for the height differences. And then thirdly, because the game is a top-down view, a lot of our playtesters have mentioned they can't see the character clearly and have asked about what the main character is. So we need to highlight our main character. And lastly, we need to improve our sound effect to help the player better understand the next move. For example, we need a differentiation for going up and down, and a clear feedback for if the players can move forward. And then we definitely have a lot of positive feedbacks from playtests. Most of them have mentioned they cannot stop playing our game and want more levels. And now let's hand over to Richie to talk about more UX and visual improvements.
Thank you, Cassie. Here, let's talk about the iteration process of our game experience. So first, we intend to imitate the user interface of Uber Eats, trying to convey the theme of delivering food inside a big city. And some of the players didn't recognize the timer bar, so we later associate the timer more with the destination icon you can see on the left. Yes. Using color and emojis to strengthen the feedback, making it more immersive and intuitive to read. For game information panel, we deleted unimportant informations and improving the UI look and feel. So at the starter screen, we also show a small cutscene featuring our main character, introducing it so the player won't be confused by only seeing it from the top-down angle. And inside each levels, we added indicators to the height difference, making it easier to quantify and encouraging the players to look from side to side. Between each level, we added a level end screen to strengthen the feedbacks as well as strengthening the connection between colors and how well players are doing. Here are some more visual improvement, including visual effects, character animation, and lighting and materials in the level.
So to conclude, building on the insight from previous demos, we created Cat Dash, a fast-paced mini-game on the looking glass display that challenged players' spatial observation and quick decision-making. So for future step, looking ahead, if we have more time, we would like to increase depth perception to utilize more left or right head movement. Features like observing the side of buildings to know whether it will collapse or not, and also things like avoiding objects falling from the top. Additionally, expanding the game with a wider range of levels and obstacles will enrich the experience, offering players more varieties and challenges. And since Looking Glass have both smaller and larger screen, we wanted to optimize the game to different sizes of the screen. And we believe that these improvements will help refine Cat Dash into a more immersive and polished 3D game on the Looking Glass display platform. And that's it for our presentation. Thank you for listening, and we are open to any questions.
Is it safe to say this is the only Looking Glass game?
We could say, yeah. I've been lurking on their Discord server for Looking Glass, and so far, what I've seen, not a lot of people have tried to build games with it.
Do you have plans maybe for making it real, like launching it?
You want a really real question, like really honest question, honest answer, or a answer mainly for? Okay, yes, I'll give a really honest question. I'll give a really honest answer. So yes, we are planning on, not planning on, we already scheduled a meeting with Looking Glass to see, for example, if they want to use this as a demo or use it as something in their ecosystem. And moving forward, if this somehow becomes a hit, because have its platform or have its audience, we do plan on iterating a bit more. However, so far, since we're all graduating, every single one of us is graduating, we need to check that plan in the future, see how everyone's doing in next year. So.
What was the other answer? Not yet.
The other answer is really short, is we're graduating, we're not doing it.
So following off of that question, Charles's question, so if someone does want to develop more games with this, what type of games would you recommend they try? Do you have any red flags like, oh my God, never? Or what would you say is a nice, safe green zone to develop in?
Thank you so much for asking that, because that's really a lot of pitfalls that we ran into. Is sometimes, like, when we're making the experience, we keep thinking about, like, yeah, any 3D will do. Any 3D that you can look around will do. However, it's not the case, because tying really the sense of depth, or like using that depth to tie together with gameplay is not that, it doesn't have a lot of cases to do that. We thought about prototypes like this, like the building, because we've gone through a lot of trials and errors, and when we first put in the egg experience, really the answer we got from more people was that probably plays the same when you're using a normal screen, and that's also for the second prototype we're making. So putting 3D things on the 3D display will look really cool, but sometimes it may not have a lot to do with the features that it actually brings. So it depends on the people, like what they want to do with it. Sometimes looking cool is enough. Like sometimes looking cool on the 3D display screen, that's good enough for you to sell a copy of a game. However, it's kind of like the similar thing of making a game emulator, like moving League of Legends to mobile, comparing to games like Infinity Blade, comparing to games like Angry Bird. Like you started out with these games or experiences that really based on what this platform excels at. Do we have more questions? Yes.
Could you talk a little more about how you came up with this 3D skyscraper example idea? Because I think it's an interesting story, but I don't know if everybody knows it.
It's a painstaking story that we fought a lot. That we literally have times that we refuse to talk to each other because we all believed like our idea is superior. So we've gone through a lot of that. However, we did manage to filter out a lot of these kind of emotions out of the game development phase, and really concluded on things that we can actually see. Like essentially we nailed the idea by building something. We nailed the idea by throwing some blocks onto the screen and say, this kind of looks nice. Like jumping between blocks and being able to sense the, kind of tricks you into falling from height or climbing up a mountain, like climbing up a building. That eventually kind of nailed us. Also, it was a lot of confirmation from our instructor. Derek really liked the last one, the last prototype. He kept pushing us on it. Although I had a lot of doubt, honestly, in between before the art assets came in. I was like, these are just some gray blocks. That doesn't look great. But I believe it's really a team effort. It's really a group effort of us struggling through a lot of iterations.
And adding on to that, that's where you see the magic of like letting go of your ego and then sit together, dumping some ideas and just go on and yes and. Yeah.
Yep. It's time. It's time? All right. Thanks, everyone.
Mic check?
Only the strongest can survive.
Mic check.
AI opponents have arrived. Mic check. Make your rap dream come alive.
Mic check. Oh, thank you. Now wait till you see the rest of our presentation. Good afternoon. Thank you for joining us. We are, as you guessed it, Mic Check, the Rap Battle AI project, and we will be showing you how we balanced guidance and freedom in an AI-powered experience. So this is our lovely team. And this was originally a faculty pitch project by Mo Maller and Jonathan Walton, and our consultant was Heather Kelly. We also had some wonderful SMEs, Charlie, Kinenjuku, Solman IT, and together they've been helping us throughout the semester. So we wanted to leverage generative AI through the medium of rap to empower players to express themselves creatively, making our 3 pillars of the project rap, authenticity, Gen AI, and creative freedom. To do this, we developed a game that tests the players' writing skills by pitting them against AI opponents in a rap battle to become the rhyme writer. But it's better to show you than to tell you.
Okay, so you're Ace, you're at the Beat City subway station. You want to become a rhyme writer. You know you have it in you. And you're here to battle Flygle and beat her in a rap battle. So you need to first find some information. You want to know what the audience likes. You want to know what Flygle's weaknesses are. So let's talk to some people around. That guy right there, yeah.
Blah, blah, blah. Blah, blah, blah.
Oh, hey, did you know Flygle only wears clothes inspired by sea creatures? It's totally a vibe. I'm all about ocean metaphors and rap too. Did I see the notebook emoji react? Let's see what updated. Oh, The audience likes metaphors about the ocean, so maybe that will be helpful in the raps we write. Let's try and find some Fly Girl's weaknesses. Let's look around the station. What are those, fries? Let's press E to interact. Did Fly Girl leave all these fries lying around? What a waste. I should ask about this. Maybe we should go find Fly Girl. Let's have her. There she is. Can I help you? Like, why are you in my face? Why did you leave all these fries lying around? Did you just say French fries? Whatever, I literally don't care. I think the notebook updated again. Let's see what we have. Oh, one of her weaknesses is that she misses eating fries. We'll definitely be using that. Now we're ready for the battle. Let's get into it. So we have 3 modes here. There's rhyme sets, lead-ins, and bar for bar. We'll go more in detail in our rest of our presentation. Let's start with rhyme sets for now. Here we'll complete a sentence, and there will be a verse provided, and the last word has to be filled in. I guess Fly Girl's going first. Yo, Ace and Fake, Jordan's trying to look fly, but you can't touch my sky. I'm the queen of high. While you're busy trend chasing, I'm busy trend basing in this rap made with my glory that you're facing. Okay, we gotta write our rap. We gotta show her what we're about. I think I'm gonna boast about being cool as an ocean breeze. And maybe we'll diss about her not having that fries. You can't even have a fry. Let's see what the AI generates for us. Okay. And cool as the ocean breeze, living life without a worry. Chilling ease, you struggle, can't even eat your fry curry. Yeah, like that. Stepping up with style, while you're a mess full of lies. I'm the Fresh Prince. You're just still trying to survive. Okay. Let's see how we did. There will be a score that will come up right after the audience is judging us. We did pretty fine. It's okay. Yeah, that's it.
Okay, thank you so much. Y'all are too kind. Sorry, that was in case our demo didn't work. So our biggest challenge this semester was balancing guidance, freedom, and the AI experience. So thinking back to our pillars, we were able to set the context for the game to help us design towards a specific experience, and the tool in which we would create that experience, Gen AI, but creative freedom was a little bit more complicated than we had expected. So throughout playtesting, we figured out that in order to express themselves creatively, players needed just enough guidance to understand how and where they can be creative, but not enough to stifle their creativity. So we developed these 4 different strategies that we're going to be talking to you guys about today to help us do that successfully.
So here we are going to talk about our decisions we've made. Our characters are at the heart of this world, and we want them to feel like they belong in a vibrant underground rap scene. Ace's outfits mixed with streetwear staples like oversized jackets and utility pants with bright yellow tones that match their bold, passionate personality, while Fly Girl has these sharp angles and props of pink to reflect her flashier, even more dramatic vibe.
To support our still life look, we used a cartoonish modeling style with vibrant color. Ace and Fly Girl's designs are detailed and colorful compared to the audience NPCs who are rendered in flat and monotone colors. And this contrast visually established Ace as our main characters. And we also added a playful, exaggerated animation system. The custom working animations can add life and rhythm to the characters.
So our game starts on the train and takes place in subway stations across the city, each one customized to reflect the background story of the rapper you meet there. With carefully designed lighting and color contrast, we highlight all the interactive objects and the characters to make them stand out against the background.
For example, for the entrance scene, we used graffiti, posters, and advertisement signs to support environmental storytelling. And the beach city station scene has ocean motifs, bluish lighting, and neon wave shapes, which matches Fly Girl's background story as a seagull. To guide the player's experience,
We also design the audience and the interactables in different positions, so you can collect important information before actually meeting the flight goal.
Our UI style further set the tone of our game. We used bold graffiti-inspired panels, hand-drawn outlines, and high-contrast colors to create a street-smart, high-energy aesthetic. Everything was designed to feel cohesive and expressive, making the entire game feel alive and interactive.
So along with the visuals, the gameplay also impacts how we guide the player. So you research your opponent, you collect information that you're going to use later, and then you engage in the rap battle, which sounds pretty straightforward, but we observed that when players enter the games, they were lost and confused. They didn't know what to ask or what they were looking for. So although the freedom that comes with AI is exciting, it is also paralyzing. We needed to guide the player more to make use of it. So we started questioning how we guide the player without giving too much away. So one of the first things we did was we added an intro video that introduces your character Ace and their motivation to be in the station, to become a rhyme writer. Then we started to have an intro dialogue to explain to players the things they need to find, the audience preferences and the opponent weaknesses. And then in the subway, there are also clues like the fries that will prompt you to ask for specific topics that will help you. And originally, you could only talk to your opponent Flygel, but we also added the audience members for multiple sources of information. But even with the more and more clues we added, we were still struggling to get the players to those clues. So we had to utilize UI and sound effects.
It's hard to notice, but here are our UI designs scattered in the game interface, like the objective board reminds them of their goal. Exclamation marks and chat box tell them to interact with objects and NPCs. Highlighted keywords show them their next steps, and also sound effects play when they walk past something important to remind them to check it out. When they get information, it's highlighted again, paired with a writing sound effects and a notebook animation, prompting them to open the notebook and reinforcing its importance. When players talk to different audience, both the UI and gibberish sounds change to reflect who they are speaking to. Gossipers have a neutral, flat, medium-pitch sound. Fans have a higher pitch that rises, and haters have a lower pitch that falls. While we have a lot of guidance for players to collect information in the pre-battle stage, they now have to find the right flow to use that information in the rap battle. The rap battle stage gives the player more agency to creatively express themselves using the information we collect and gain confidence. Without completely giving everything away, our game structure helps teach players the order of writing a rap, help them choose a mode they feel confident in first. Next, decide what to boast or diss about. Then complete a rap with AI's help. And give feedback scores in the middle of the game, also at the end, to show where they perform well and where they can improve. During our past playtest, we got a lot of feedbacks from guests saying that they want more freedom in writing and more reactions from the audience. At the same time, we also wanted to support players who aren't as confident to write too much or have lower literacy.
So to address these mixed feelings, we had these different modes: rhyme sets, lead-ins, and bar for bar. So rhyme sets, as you saw in the demo, give you the freedom to finish the end of the sentence with one or more words. And this was originally our original mode and very constricting because it felt like there was a right or wrong answer. So we had the editing mode so that you could change what the AI gave you to expand what people would want to put in. Lead-ins will regenerate half of the sentence, so we set up the context for which you can complete the bar, but you get to conclude the rest of the sentence. And finally, bar for bar, where we create the first and third sentence and the player finishes the rest. So most players thought about rhyming in couplets and we're using an AABB rhyme scheme. And this mode caters to both of those, a couplet assumption and also pushes them to use different rhyme schemes. So in all, letting the player choose the preferred writing modes gives them agency over the way they want to be creative and how much guidance they feel comfortable with. And when they're scored, they feel more rewarded for their cleverness.
Our scoring system includes audience choice and round scores, which give them constant feedbacks, and the final result that give them a reward and a push to dive back in and try again.
Following the design side, I'll show you how we handle freedom and structure behind the scenes, embracing the messiness of generative AI. There are 5 core AI components in our game, and each handles a distinct part of player experience. The chat component handles all conversations between the player and NPCs. The battle component generates rap lyrics for our rapper opponents. The detect component spots mention of certain information in the text content. And the assist component, this is the writing assistant for our player. It generates incomplete verse for the player to fill in. And finally, our score component, well, it scores rap. And none of these components works in isolation, and this is how data flows between them. But don't try to look at the chart. I just want you to have an idea of how messy it is. And the real magic comes from its messiness, comes from how they interact and share information. And this is how we make our gameplay context-aware and meaningfully reactive. Let me illustrate how this works through examples. From the moment you met Flygull, the system maintains a shared history accessible by both the chat component and the battle component, which means during a rap battle, Flygull can bring up details from your prior conversations with her. That's when things can get really personal. And when the player is chatting with Flygull, she can also reference or comment on the previous rap battle you had with her. Another example is our scoring system. It doesn't just look at the rap lyrics in current round in isolation. Whenever a player references an opponent's weaknesses or audience preferences, the detect component will let it know and impacts the score. It also looks at the rap battle histories in previous rounds, allowing it to judge whether the player is building on themes or making relevant callbacks. And finally, we fit in this documentation, and Keisha will talk about that.
Yeah, so these are the documents that fuels this robust data flow system. Starting with how we maintained our chat and responses document. We first start with the foundation. These are the identity, voice, and triggers prompts for the character, which establishes a consistent foundation so that AI does not hallucinate more details. Then the reinforcement. Despite the foundation, AI can still invent more details, so we have to feed it more response and example raps so that it can say the things that we expect it to say. And then we have established guardrails, as there are things that AI knows that the character may not. So we have to make sure that the conversation sounds natural and it remains on track. For the audience, we did not develop such a deep backstory. We had a shared base profile, and the things we changed about the characters were the preferences, triggers, and example responses. We had 3 profiles. There was a hater, there was a gossip, and there was a fan. And all of these have different ways that they will reveal information when you talk to them. Coming to the scoring, we utilized certain strategies to help AI judge our raps. The first one was grouping the categories into subcategories that allows us to give depth into the scoring without overwhelming the player, range rating, and conditionals, which help the AI go step by step and rate the rap appropriately. But while we had big dreams, we had to scope smart. These are the things, we wanted a whole new level, we wanted more shaders, we wanted in-performance feedback, but we decided to be mindful of the semester and the time we had and focus on the vertical slice that we wanted to polish. Thank you, and we are open for questions. Yes, yes.
You used AI well and for 5 different things. Of those 5 things, which do you think it was performing the weakest on, and how might you prop it up better?
Thank you. That was a good question.
I will let Hazel answer this first, or like, I have an opinion.
Yeah, I personally feel like the score component is the one we want to spend more time to iterate it.
I agree.
Yeah.
Yes. It keeps, like, you tell it that this is what an internal rhyme is, and it will just forget. Like, we don't know how much reinforcement it will take to.
Yeah, and also we need to establish like a completely different scoring metrics for our player and for the rapper opponent in our game, because you can't let, like, they rap perfectly and every time they beat the player, and that's not a good experience we want.
Yeah.
I'm curious what was the decision to build a vertical slice, because you put a lot of effort into the visuals, which I think is great, but it does not the key risk for your product, right, which is the Gen AI component. So if you could go back again, would you do less visual presentation work and focus more on rap battle flow and the Gen AI component?
I think we wanted to utilize all the skills on the team, and we have a really skilled. We're very lucky to have very skilled 3D and 2D art and animation art. So that's kind of what we want to put a lot of our time in as well for our team. And I think, as Candace was mentioning in the presentation, that like a lot of the UI, a lot of the art help people like play the game better. So even if it was just like a tech prototype, I don't think it would have cultivated the experience that we would have wanted anyway. Oh, sorry.
I'm kind of curious about the practical realities of like trying to either release this or share it with the world more broadly, given that it's based so much on AI, which is possibly an expensive paid service.
Do you want to take this? Yeah, I can do this. So, so there are not so many AI games up there right now, and most of them is like more in a chat bot type of thing. And the problem to release or to sell an AI game is once the player purchased your game, the more the player play it, the more money you're gonna lose. Because they are using your tokens, and tokens cost money. It's like a pay-as-you-go. The more you're talking to your character in games, the more you're gonna like lose money on this product. So that's pretty counterintuitive. So I feel like as the emerging AI technologies, and we're more using it more and more in producing games, we need to like kind of figure out a new way to publish it. And
yeah, so some of the ways that we love this project, and we do want to continue working on it. If we were to make money or to even like fund completing it, it would have to be like a credit-based system, is what I was like talking to Jesse Shell about last week, where you buy a certain amount of credits, you can play the game for so long, or to talk to people, the opponents for so long, and then you'll have to use more credits. I think that'd be the only way to make profit as of now that we've been exploring. Yeah. Can we take one?
All right, thank you. Great game, great graphics, great assets, great delivery. My question is, so you feed the data and prompts to the AI to make it a better rapper. So does the AI make you a better rapper as well? Do you have a freestyle?
I mean, we have had repeat players. We played a set with Westinghouse Academy like near the first half of the semester, and we went back, and there were 2 kids who were playing again, and they were spitting bars, I'll say. Like, I was like, whoa. If I was Flygo, I'd be hurt.
even when I'm just like play testing this game over and over, like at first to test the tech, I just put in AAAA in every blank, and finally I can like think of words to fill in there. So yeah, it does make me a better rapper.
One question, sorry, on the publication side, is there any IP proposition here?
Can you define IP proposition? Like we own the IP, but to sell it, I think we would have to have meet a perfect audience that the generative AI game. That in itself, I think, is such a new thing to explore, and I don't know if we want to relinquish the IP just yet. We still have to discuss that. If that's your question.
Well, yeah, I mean, is there...
Are you offering?
No. Well, is there potential for an IP to emerge from this that you guys can pursue so that the idea of publication is one thing or selling it? Because there are AI agent games out there that are owned by, game companies, right?
I think we'd love to explore the possibility more. Maybe we could talk a little bit later. I think we are over time.
Okay.
But yeah, we would love that. So, thank you.
All right, and let's begin our final presentation. Just a quick overview of the team. Our client is Honda 99P Labs, and Charles is our instructor. So, today's final presentation is called, Are We There Yet? It's something that we can all relate during our family road trips, right? And maybe we asked this question when we were children. So that's the fitting sentiment of this project. The project progress itself and the family in-car experiences we designed, and the macro sense of the present and the future. As you remember from the half, we spent 7 weeks long doing research and ideation, which is not typical ETC schedule at all. But this gave us a grounded and highly relevant starting point for our experience design. As you already know, Honda 99P Labs want us to help them imagine and define the future in-car experiences so that a trip is not only from point A to point B. As the third space besides home and work/school, what experiences and emotions we can create in a car. To envision the future in 2040, we first did our tech research in 3 areas: cars, AR/MR, and AI. And after our visit to Honda 99P Labs in week 5, we found that there is a universal need among our team members and our clients that family interactions, connections in car are wanted. Therefore, we wanted to validate if such family experience is desired among a broader audience as well. So next, we conducted our interviews and surveys to generate our user personas. From the user research, we generalized the user pain points and came up with initial solutions to address their needs. Then we dived into the design process to craft engaging and meaningful in-car experiences for families. Now I will pass to Candice to introduce what our project is all about.
So, after both tech research and user research, we settled down and decided what this project is all about. So, it is a mixed reality in-car experience concept design for the North American families in 2040, featuring an entertainment experience during a family road trip to Yellowstone National Park. But why do we choose this entertainment experience to demo? First of all, it's for the core values that held by our target audience. They value family connection so much, and they want to spend meaningful family time together. Next, we want to show the future possibility for technologies, including the car seats, AR/MR, and also the AI-generated content. Lastly, we want to create an experience that relates to the trip destination so that passengers are filled with curiosity and anticipations before their arrival. So here's an overview of the experiences that can happen during a family road trip in-car experience. An entertainment experience is in our focus. The sample destination we choose is the Yellowstone National Park, as it is one of the most popular and family-friendly national parks in the States. Within the Yellowstone National Park, we chose 2 specific elements, the Old Faithful Geyser and also the bisons, as the educational objective for our experience. In the geyser experience, the family will learn the geographical facts about the Old Faithful Geyser, and they will set off the geyser together. In the bison experience, the family will learn the animal habits and feed the bison with the right type of food. Okay, so that's before the half. But are we there yet? Of course not. So next, I will pass to Yihua to review our playtest day.
All right, thank you, Candice. So playtest day. We focus on building the demo and setting our playtest environment in the second half of the semester. This is how we set up the Mobility Experience Lab, and we really appreciate Dave's help of helping us for the setup. So here, first we make the wood platform to raise up the seats so they can actually be at the same level as the actual car seats. Second, we decorate the exterior with cardboards so that they can be more decorated. So this is how it looks like now. Although the car looks lo-fi, but the overall layout and the indirect control can give our playtesters a feeling of actually sitting into a car. On playtest day, we tested our geyser experience. As you can see, there are some screenshots. Here are some playtest pictures on the day. As you can see, there were many family members coming to our playtest, giving us a lot of critical and informational feedbacks. As they say, like, if the kids are happy, the families are happy. So playtest day check, but are we there yet? Not really. So let me just pass to Alex to review our soft opening.
Okay, thanks, Sihua. So soft opening. So by the time of softs, we both have the geyser and bison experience ready. And here are some pictures we took on the day, and ETC faculties gave us many constructive feedbacks. So what went well? So playtesters generally like how they were very close to the bison so they can feel what's their real size, and also sitting face to face felt like the future of mobility, and also they can relate to their personal family road trips. But there are also a lot of improvements we should do. So people were saying that, okay, they cannot feel the real size of the geyser, and also too much narration, not leaving enough space for natural interactions of families, and also the initial tapping gesture we have for setting up the geyser was not intuitive and related to the like kind of mechanics of the geyser, and then just general kind of we need more guidance and tutorials in our experience. So lessons learned at soft opening, but are we there yet? No. So I will hand it out to my team to talk about the development and the concept video.
All right. So I'll talk about the development process. So in order to replicate the future and help us to imagine, we use Vision Pro and Reality Composer to develop our prototype. Given the time and number of device constraints, we decided to build a two-player experience, and we use Firebase server to sync the game flow, and also use occlusion material so that players can see each other more easily and create a sense that they're sitting in the same environments. And the first experience we have is Old Faithful Geyser experience. As you can see, there are two progress bars. One represents heat, one represents pressure, which are the two factors that enable the eruption of the Old Faithful Geyser. And this is the interaction in the experience. So the players will clap their hands and increase the progress bar. And once both the heat and pressure reach the limits, they will enable the eruption of the geyser. And we also have some educational content for the Old Faithful Geyser to learn more. For example, on the left, we have the geological structure of the Old Faithful Geyser, and on the right, we put the Leaning Tower of Pisa to indicate the heights of the geyser eruption. And next, when the player enters the natural habitat of the bisons, will trigger the bison experience. And there's also some educational content in this experience. So player will have this basket. The basket will have some wrong foods that bison don't eat, like the flowers, the apple, and the bananas. And it will also have the correct food, the bluegrass, that bison will actually eat. And when players are feeding the bison with the wrong food, the bison will shake their heads and provide a negative feedback. And when the players are able to feed the bison with the bluegrass, the bison will come closer, and the player can interact with the bison. And next, I'll hand to Asmi to talk about the art.
Thank you, Bonnie. So, to achieve the most realistic visuals and explore the forefront of future lifestyles, we employ various technical approaches in creating our art assets too. These include the standard PBR as a production pipeline, the terrain generation based on the real map, and also the experimental use of AI-generated contents. With art integration happening in the brand new Apple developed engine Real-Light Composer Pro, we also face various challenges in visualizing lots of effects. However, we learned through the different functions in Real-Light Composer Pro and achieved our production goals. So, in addition to our demo build, we also plan for a concept video demonstrating the full set in-car experiences during a family road trip. For the pre-production, we outlined the storyboard, shot list, camera, and lighting plan. We also invited Dave and his daughter Hazel to be our guests and actors to join the filming. They did a really outstanding job, and we truly appreciate and enjoy their performances. Once we have filmed all the raw footages, we started assembling, compositing, editing, and sound design to make the concept video come together and get ready by our client's visit. And now, please enjoy the concept video of family mobility experiences in the future.
A new day, a new way to travel begins. In 2040, the Honda experience reimagines your family road trip with interactive moments. It's time for something fun. There's nothing like a game to make the long journey more joyful. Enjoy family time in a new way, on the go.
Together time is great,
but a little alone time can also be good. Then we have
time to relax.
time to relax. Music mode is a moment for stillness on the move. Time for focus and maybe a bit of work for others. Calm, clear, and connected.
Business opportunities I think could be really valuable for both sides. It's still early stage, but I'd love to get your...
Traveling is about learning
new things too.
We just entered
Yellowstone National Park.
Old Faithful
erupts naturally every 90 minutes. Let's see if we can help it erupt. There are bison up ahead. They are powerful and among Yellowstone's oldest residents.
Do you think they're hungry? Guess which one is the right
food for the bison?
Immersive technology
enables interactions that are impossible to experience in the real world. Have fun and learn.
Now you know the land.
And the land knows you. Welcome to the future of travel.
All right, thank you for watching. Great job, Dave. All right, let's review our client visit from last week. So on Wednesday and Friday last week, our clients visited us at ETC. And we did our final presentation in front of them and let them try our demo. And as you can see, they were quite engaging and interested in it. Great job. All right, so now, everything is done. The semester comes to an end. But are we there yet, honestly? By the end of this project, are we getting closer to the future of 2040? Are we there yet? Before answering this question, let's look back at the New York's World's Fair in 1939, 100 years ago from 2040. The theme of the World's Fair was called The World of Tomorrow, and its purpose was to envision the future in 1960, 20 years after the event. There was an exhibit called Futurama at this event, designed by the famous American theatrical and industrial designer Norman Bel Geddes. There were two things special in this exhibit. The first thing was the concept of a network of expressways connecting the nation. And the second thing was an early depiction of automated guided cars. So maybe these two things were not widespread in 1960, but look at them right now. And maybe our idea that a trip is not only from point A to point B might not come true by 2040. But certainly, we have seen the future, and now is the time to build the future of the third space. And thank you, everyone. And now we are open for questions.
So what was it like to work with the Reality Composer? It's its own content creation platform made by Apple. There's no third party or anything outside of that. How feature complete was it? Did it have what you needed?
Short answer is it's not complete. I think we initially decided to use it because it provides it's the natural Apple engine, so we imagine there's less compatibility issues with it. But it is a quite new platform to say, and it's they're trying to build a game engine, but there are definitely some necessary functionality missing to be a complete engine. We found that in order to build functionalities compared to Unity or Unreal, we kind of need to almost reinventing the wheels. So the short answer is not complete yet, I think, for now.
How did working with an automaker like Honda, going back and forth, change your philosophy on the project from the beginning to the end? How did that interaction with a commercial company sort of change your project?
We really appreciate Honda as a client to give us help and support every week through weekly meeting and also their feedback. And we really appreciate this experience because through this experience, we learned that the design process is not linear, and also the core of design is always realized not to our clients, but to our customers. The core of design is always human. We always rely back on the playtest and also feedback from our users and playtesters to give more additions and also more iterations on our products. And this is a very important lesson to learn, to how to balance the pace of usual ETC production line, timeline, and also the actual production in industry.
Yeah, as we mentioned, we almost spent the first half of the semester on our research and ideation. That gave us a grounded and highly relevant starting point for our experience design. And then I think Honda taught our team that we really have to understand the core values held by our customers. As technologies will change along the time, but people hold very similar core values in this timeline. So to understand your customers first, and then you create the technologies to satisfy their needs. I think that's something that is really valuable. We learned from this project. Yes. Okay, thank you.
So, hello, welcome to our final presentation. We're team Hello Alice. My name is Eva. This is Sanqi, Wendy, Jia, Jingyi, and Yifan. And our project instructor is Dave, and our consultant is Chris. And our client is the Alice team, and we have been working with Melanie and Daniel throughout the process. And our mission is to reimagine coding education beyond dragging and dropping with AI assistant for 10 to 12 years old students in a classroom settings. So, how do we start? So the initial prompt we get was very open-ended. It was almost like a VR storytelling idea, but it also gave us a lot of freedom to define our direction. The most important question is, how can we use AI well enough to support our programming educational goal? So the team started off with doing brainstorming. We pitched ideas that are really diverse, but all touches some points to bring AI into coding education. So after the idea pitch, we solidified our direction to best answer the question. We decided that we are building our tool PC-based, using natural language as the main input, and integrated storytelling to support our programming educational goal. The reason behind that is that PC-based makes it good for classroom implementation. We also wanted to introduce intuitive input, so natural language became our main choice. And to continue the learning, we believe that storytelling will be a great motivation and medium to do so. And our educational goal is to teach decomposition, which is a core concept in programming education. Decomposition means breaking big idea into smaller parts so that it can be better implemented. For our tool, we deliver the idea of decomposition by first having players to deliver the idea to AI. AI will handle the breakdown, and then in return, the players will get corresponding code blocks and corresponding assets that match the idea. We visualize the breaking down process to them to help them learn better. So, we are now building a PC-based programming educational tool that teaches decomposition with the help of AI. And students will create a 3D interactive story using natural language. And now let's take a look at the tool.
Okay, so we'll have a brief live demo to walk through the user flow of our tool. Showing? Okay. And so now we are on the start menu. This is where we can choose who and where we are. So first, we can choose our avatar. This is one thing we have noticed in the early play test, that kids can be encouraged to create stories if they can choose their avatar. So let's imagine we are a druid, and we can imagine what we can do. And on the right side, we can select whatever things we want to choose. So let's start with the forest, and we can add a castle scene. And now we are on the editor mode. So on the left side, we have the game view. This is where we can walk around, explore the world, and preview the spells we have made. On the right side, we have two tabs. One is Spell Link, and another one is Spell Lab. So let's start from Spell Lab. This is where we can give AI the prompts, and AI will generate the code blocks for us. And for our first spell, let's make a very simple one. Since we're druid, let's cast some spell to turn the apple to a key. And hit submit. It takes a while for the AI to respond because we're sending this information of the entire thing to it. Okay, so we can see from the code blocks, it first destroys the original apple object and then spawns a key. It might seem to be a simple action, but different from how we normally perceive the transforming as a simple step. We want the user to realize that to think as a programmer. So it first releases the pointer that original points to the apple, and we point it to the key that's being spawned. And another advantage of using AI is that it can take very abstract comment and decompose it. So let's make another spell. This time we will make a tea party in the forest. Make a tea party. So when the AI is running, we can introduce other functionalities. For example, here we have the history button. We can go back to the spells we previously made and edit it at any time. Okay, it's done. We can see it decomposes the spawn Tea Party action to spawn different objects, but we can see some of the rotation of the chair isn't very correct. So we can also manually edit it. We can type in rotate the chair to make it spawn rotate chair action. Okay, so now we can manually edit the rotation of the chair. Let's make it right. Okay. And move this chair a little bit farther. Oh. Okay, so now we have our functions ready. We can go back to the spell link. This is where we can link our spells to objects we selected. So first, we can bind our transform apple action to the apple and hit the green button to preview the function. So here we can select the key and add the spawn Tea Party function to it. And let's double check if it's being added. Okay, I forget to save this. And then click the button on the top left to enter the play mode. And we can get closer to the apple, hit E to interact. Wait 1 second. Transform apple to key. I think it's correct. Yeah. Okay, and it's being transferred to a key. And press E, we can see the Tea Party. Okay, so that's basically the workflow of our tool.
Okay, thank you, Yifan. And then let's talk about the AI. And then let's talk about the AI integration in our project. We are using Unity to develop the tool because it works very well with 3D art. However, C# is not the perfect language for real-time compilation and execution. Besides, asking AI to generate a whole C# script can be risky because incorrect code may cause unexpected behavior or even crash the whole program. So to address this, we introduce a Lua scripting layer between the AI and the system. And when AI-generated code is received, it is executed in C# with error handling. This approach constrains the AI behavior and ensures the stability of our program. And also, the original Alice has its own programming language, and the idea of adding a scripting layer to translate one language into another can also serve as an inspiration structure for our clients. And now let's take a look at the method we exposed to AI. Here's a short video showing them with some examples prompt. We organize the method into a few categories. First are object-related actions. We have move, scale, and rotate. And if the show action checkbox is on, these actions are animated automatically. And you can also spawn object we provide, destroy the ones you don't like, or just simply change the color. And for the game feel, we added a method like playing some very cool visual effects or destroying the existing visual effects and play a sound. And also, you can add googly eyes to any interactable object. And for the game logic, you can show the AI-generated dialogue or just switch to another scene and adding delays between different actions. And for the character, we allow changing its size and playing animations, and this was a favorite part in our playtesting. And also, all the code blocks are editable. You can always change the value of the dropdown and the checkbox, and the changes are applied in the scene immediately. And then let's hand it to Zhanqi for the changes we've made in this project.
So along the way, there are several decisions we made to build up the tool. For the art, our target users are 10 to 12 years old kids, so we choose a hand-painted art style and we choose setting of the field a little magical, but not too far from the kids know, like a forest. The scene choosing also helped avoid confusion. In a magical forest, no one should expect a car or drive a car. This supports an inviting storybook-like world that encourages experimentation.
For our iteration, our scenes went through multiple iterations. At first, we filled the ground with grass, but later we found the blocks that wheel. We also started with many decorated assets in each scene. However, they ended up confusing players. So we simplified the scene to make the interaction clear and more meaningful. To encourage creativity, we also give the every object googly eyes so kids can treat them as characters. During the playtesting, we found the players are excited by VFX interactions. They loved setting things on fire, explosions, and watching the scene change. These moments give them surprise and satisfactions.
We are exploring a new direction in AI educational tools interface, so we spend a lot of time playtesting with different stakeholders, including kids, educators, parents, programming experts, and non-experts, and then iterate our UI UX based on how they use the tool. And this is our first version of the UI interface. Then by using interactive Figma to rapidly prototype our design idea, we quickly iterated and tested new UI interface based on some key insights from playtests. For example, we add history function to allow the users to check their spell history and make changes to them. We also use sentence lines formats in the Spelunx mode that feel more intuitive, and we change the terms into more fun and simple words as our target users are keys. We also need to help our players understand the balance between what they want to do and what the tool can do. So, for example, during the playtest, some players are not sure that the mountains can be modified and they can only add spells onto an interactable object. So we add a whole effect onto the object that can be interacted with to provide clear clue. To illustrate our tool's ability clearly, we also designed a spellbook to guide the users through confusion and spark new ideas.
So in order to define whether our tool is working towards success, play testing with our target audience is very important. So we had our final play test with students 10 to 13 years old at Kentucky Avenue School. We observed the reaction of the students and what they're able to create with the tool. Turned out that they had a great time playing with it. And one story really captured what we aimed for was when a student began by creating a door. And after the door appeared, he thought, what if the door could take me to somewhere else? From there, he made a prompt to make that happen, linking actions step by step. This showed how the tool supported both imagination and logical thinking. Students were able to decompose their idea into actions, which is exactly the kind of learning we hope to inspire. One of our goals was to see if they understood the connection between their input and what AI can generate. We noticed that they figured out the changing values in the code blocks would directly impact their story. They also recognized patterns, for example, realizing similar prompts produce similar outputs. This led them to experiment more, refining their prompts and testing ideas repeatedly. It was great to see that blend of creativity and problem solving.
So what are the next steps? So we offer AI implementation, documentation, and a detailed guide of our tool. Through the development, we have an implementation framework that proves AI integration works. Also, our use of Lua for AI integration can serve as a strong reference for Alice Tweedle development. And also throughout the playtest, we discover how visual effects can really enhance the learning motivation. So we believe adding visual effects can be a wonderful implementation for future Alice. So to sum up, our mission is to reimagine coding education beyond dragging and dropping with AI assistant designed for 10 to 12 years old students. And we're building a PC-based programming educational tool that leverages AI, enabling users to create their own 3D world using natural language. Thank you for your listening. We're open to questions. No, I should. I'll be good at it.
So the world of coding with AI is still very new, and so the right way to teach it to kids is still something everybody's trying to figure out. What, as you started having people experiment with this, what are some of the limits you found? What are the things that kids wanted to do but couldn't do?
First, some of the limitations are set by by our team, because we cannot expose all the functions to AI, and then AI will generally just use everything, and we cannot constrain the output. So we only choose to expose some of the functions through the Lua function to AI. That's why sometimes the kids might want to do something, but we cannot do that because we don't have a function to it. And besides, through all our playtesting, we found that it is very hard for AI to correctly handle the space relationship between different objects.
Thanks.
Seems like your use of AI here is to kind of serve as this kind of magical answer for interaction.
Yeah.
And another approach is to use AI as a teacher. Did you find that manifesting in this approach at all, or can you talk about that? Have you looked in that, or have you thought about that?
Sorry, but I'm not very sure about the teacher you said. So AI act as a teacher to teach the kids how to program?
Right, so that there's more of a presence of it guiding you in how to program rather than you prompting it and getting results back.
That'd be a good idea, but I think throughout the ideation process, we always thought of AI as being like more of an assistant, like helping them do things instead of guiding them, teaching them. We visioned that this would be work more like in a classroom, in a workshop, where there'll be like a real teacher talking about like delivering those concepts to them.
So your design approach was more to have a real teacher present. Okay, got it. That makes sense.
Time for more?
When the kids were constructing, did they want more nouns, more art, more objects, or did they want more verbs, more actions, more programming? What were they running into limits more?
Nouns. I think for most common thing they ask for are for more assets, like they want a pet, a cat into the tool. But that is also one thing that throughout the development process we've been thinking about, because we're not able to provide everything to them. So we listed out what we had and kind of asked them to brainstorm from that starting point, like seeing what they could do and what they made with it.
And I think from the playtesting, the kids were very satisfied with all the visual effects. Yeah, they were trying a lot of them. Yeah, something like that.
Thanks, team.
Thank you.
Okay, hi everyone. Welcome to our final presentation. We're Team Dreammeow. This is our team, and our instructor is Heather, and our consultant is Shirley. We are working with Ian Cole, who is the Chief Innovation Officer at Give Kids the World. And let's recap some background information about Give Kids the World. It is a nonprofit organization in Kissimmee, Florida, and we're working on an experience that will be installed in one of the attractions there, the Wonder Lab. It's a makerspace where they introduce STEAM concepts to kids in a fun and interactive way. So let me show you a demo of our project.
Botmania is a collection of 3 fun motion tracking experiences. As you can see here from our HAPS presentation, we had 3 working prototypes, but they all lacked clarity in terms of game mechanics and UI. Now, let me introduce you to the fully upgraded version of Botmania. Let's play! Meet our 3 cute mascots from the Wonderland and help them build a rocket. By doing activities with them, you are making the rocket faster, more efficient, and more powerful. In Wong's game, our tutorial teaches player how to use both hands to connect wires and complete circuits. There are 4 levels with increasing difficulty, allowing the player to enjoy solving circuit puzzles. In Mage's game, players do color mixing. We introduce CMY colors and ask players to mix them to match a target color. By doing this, they are creating more efficient fuel for the rocket. The color is also reflected on the rocket model, letting players customize the rocket to their favorite color. Finally, we have Bill's construction game, which focuses on fun and interaction with tangram pieces. Completing puzzles upgrades the size and design of the rocket model. All games support multiplayer, and kids can choose whether to play cooperatively or competitively. During the experience, players can launch the rocket on the main screen at any time. The rocket's appearance and VFX during launch animation change depending on how many levels were completed across all activities. That marks the end of the experience, but hopefully they'll want to play again and try some new combinations.
So prior to HAPS, we identified these 7 design goals and began building prototypes. We spent the second half of the semester refining and testing our experiences with a variety of age ranges and mobility levels. Our primary focus was creating an intuitive experience that will not require monitoring from volunteers.
Thanks, Michelle. So, Botmania will be installed at the intersection of 3 distinct areas in the Wonder Lab, meaning that traffic will flow from multiple different directions. Guests will have already seen the Wonderbots outside of the building and will have already walked through at least 2 other attractions, so they will already be familiar with the theming and the characters used in our experience. So as they pass through the space, they will see this idle screen. And if they follow the animation and hover their hands over these circles, it will transition to our start screen and the experience will begin. So we designed the flow of our experience to encourage as much exploration and choice as possible. As you can see, only one of the mini games follows a sort of progression system. For the others, guests can choose which levels they would like to play and the order. If at any point one of the puzzles is too difficult, or if they're just not enjoying that particular concept, they can always return back to the start screen and either select a different minigame or launch their rocket to see what they've built so far. The ability to launch their rocket at any time allows all guests to have a complete experience, no matter their skill level, interest, or time. After a period of inactivity, the experience will reset and return back to the idle screen. We've set the base time for this reset at 3 minutes. However, we have a settings panel which the volunteers can use to adjust that timing as needed. We also want to ensure that our experience adheres to the values of Give Kids the World and the Wonder Lab. Give Kids the World has certain imagery that has special meaning. And so, for example, one of those is that the Wonder Lab uses as little red as possible. Because of that, we decided to use CMY for our fuel mixing game rather than RGB. Another core value is that the kids should be able to take the learning home with them. So for that, we have provided these physical information sheets, which Rashila is passing out, as well as an STL file, which will allow the kids to print mini versions of our physical rocket at the Wonder Lab's 3D printers. Finally, the reason why we included this physical rocket, which responds to their interactions in the game, is because we did not want this to be a purely screen-based digital experience. Now let's talk about the iterations that we went through. So as we mentioned at halves, playtesting was an incredibly important part of our process. Our biggest test came with the WonderLab playtest during week 10. This revealed to us challenges that are specific to the space, as well as allowed us to see how families want to interact with each other during the experiences. All of our playtests, whether here in Pittsburgh or in Florida, revealed specific feedback, which we then used to improve our visual, technical, and game design.
Thank you, Courtney. I'm going to go over the visual design and creating an intuitive experience. From the beginning, we were handed a creative brief, and it included characters, symbols, colors, themes seen throughout the WonderLab. With that in mind, we came up with visual elements we wanted to focus on, one being the robots themselves. Each having their own personalities, we matched the game and background elements to match them. For general menus, we tended to keep it more neutral, either focusing on the Give Kids the World Village or a space theme. With the UI, we wanted to reference how much the WonderLab was geared toward physical experiences. Therefore, the UI and the menus, any overlay interactions, and so forth, was designed to emulate physical button pushing and the animation and sound effects. So now I'm going to talk about the changes we made after getting some feedback. Our previous idle screen looked like this with the orange boxes, were the trigger areas. When somebody would walk up, this is what they would see. Many people didn't understand that it was a motion-controlled experience, so accidental selections tended to happen. We found we needed to give players a chance to understand it was hand tracking, and therefore we developed a high-tech idle screen. There are only 2 buttons to press in order to start the experience, and this gives them the chance to see their own hands and their assigned player color, and before they enter a more interactable area. This especially made a difference when more than one person is able to play the game, or at the start. The next improvements all have to deal with guests understanding the selection process. We saw that many people would drop their hands to the side in order to, like in a rest position when they were reading. Therefore, we strategically moved all menu interactions to not exist along the bottom of the screen. Another decision was changed to make the hand selection animation to a more standardized design found in many hand tracking games. And finally, another improvement we implemented was to have the actual characters change when the guest was hovering their hands over the activity. As for the ending changes, we wanted to provide some visual animation feedback that would be changing based on how much the game was played. Then, on top of the animation, we would provide them with a score and infographic based on their choices and the number of each level they finished. The score and the animation differences are a way to wrap up the experience for the player, giving them a sense of accomplishment, no matter if they played one activity or all of them. And if a player chooses to play again, they could attempt to help more people and see more of the animation.
Thank you, Melanie. Now I'm going to be talking about some of our technical design, starting with our biggest piece of feedback, which was that the hand tracking felt very shaky and unstable. This resulted in lots of frustration since players weren't able to make selections with ease. This also presented problems with multiplayer, so each player has its own assigned hand icon color, and sometimes they would swap throughout the game. So for example, if player 1 was pink and player 2 was blue, throughout the game their colors would swap, which resulted in lots of confusion about who is who. To improve tracking, our first change was to add more stabilization techniques within our code. This includes implementing a frame buffer that takes the average of previous frames for smoother movement, as well as limiting movement intervals so that the hand can only move in larger distances, which blocks small jitters. We also increased the size of our colliders, both for the hands themselves and our interactable game objects, which allowed players to be less precise with their movements and still trigger the interactions. Our second improvement was that we switched from the free to the paid version of our package for Connect and Unity integration. Unlike our previous version, the new package keeps consistent IDs per skeleton across multiple frames, which lessen the occurrence of the multiplayer color switching. Lastly, we added a settings page where camera variables can be adjusted in real time. This includes the left and right culling distances, as well as the minimum and maximum depth. This was especially necessary because we found during our WonderLab playtest that the camera was actually seeing through the doorway and picking up people who weren't playing, which greatly confused current players. These settings will allow us to make quick modifications for our install this week, as well as give volunteers flexibility if they ever need to make future changes. One very important observation we made during playtesting was that each player has a unique movement range and preferences. We need to accommodate for people of all heights, from short kids to tall adults, as well as those who may have movement limitations and may be in wheelchairs. One unique observation that we made was during our WonderLab playtest, we noticed that some parents had the tendency to hold their children's hands and kind of play the game for them if the child was too young to do it themselves. But this would create lots of issues for our tracking since the camera would see 2 skeletons very close to each other. So we added an alternative controller option using a standard Xbox controller for future easy replacement. And this allows players who are unable to or just don't want to use the motion controls to still be able to participate and play collaboratively alongside those using the camera tracking.
Thanks, Malaya. So one circuit game is undoubtedly the most complex of the three, since it introduces players to real circuit concepts step by step. Level 1 teaches the basic idea of a circuit and a short circuit. Level 2 introduces conductivity. Level 3 explains the functions of resistors. Level 4 combines everything together as a final test of understanding. One interesting challenge we faced was that many players forgot how to disconnect nodes immediately after they completed the introduction tutorial. This was surprising, as the tutorial clearly demonstrated the process, and the players seemed to follow it correctly at the time, but the information simply didn't stick. We did some research on learning principles and finally figured out what was missing: meaning. Although we taught players how to connect and disconnect nodes, we never explained why it matters. As developers, we knew it, but for new players, the actions felt arbitrary. There was no context. According to constructivity theory, learning happens through doing, but more importantly, through meaningful doing. If the task lacks context, the brain processes it shallowly, making retention unlikely. In our original tutorial, players were performing actions mechanically without understanding their purpose. Our solution was simple. We moved the introduction tutorial into a real circuit environment that mirrors the actual gameplay. Now, players must connect or disconnect nodes to make the circuit function. The task has meaning and consequence. And I'm proud to say that after this small change, almost every single playtester remembered how to disconnect. Mage's field mixing game went through a shift in design focus. Initially, we aimed to create a playful, open-ended system where players could freely mix colors. It was more toy than game. But in practice, players felt lost. Without clear feedback or goals, their actions seemed to lack consequence. They couldn't understand the cause and effect. To address this, we introduced structured levels. Easier levels now show broad goals like green or orange, while harder ones show specific target colors. This gave players clarity and direction. But we still want to preserve creative freedom. So after completing the core levels, players unlock a free mode where they can mix any color they like for their rocket. Build's construction game, while the simplest, essentially a tangram puzzle, also got a thoughtful accessibility enhancement. We added a bit of gravity to the pieces so that even shorter children can reach them more easily.
Thank you, Aaron. So when it comes to our gameplay, although we are making 3 different mini-games, we wanted to make them centered around the one mission of making a singular rocket. And therefore, one of the important things was for us to make sure that the impact of the games was shown on the rocket. Initially, we had the 3 different mini-games impact 3 different properties of the rocket, that is the speed, efficiency, and power. However, the players did not notice it because most of the changes in the property were shown through VFX and animations, which happened after they launched the rocket. And to solve this, we decided to add visual changes to the in-game rocket as well as the real rocket, as can be seen here. So additionally, we also added a rocket inside each of the experiences. So whenever they complete, let's say, a level in one circuit game, they can see the lights on the rocket light up on the screen. For Mage's fuel mixing game, the rocket is constantly present on the screen so that they can see what color they mixed and how it affected the rocket. For Bill's game, after the completion of each level, we show what their previous rocket was and what the new rocket is to make it clear how they have upgraded the rocket. And this is the gist of how we reinforce the changes in the rocket for the players. Now I'll talk more about the installation details. So our plan is to fly to Florida tomorrow, that is Tuesday morning, and reach there by afternoon. And we plan to set up our game at the Wonder Lab tomorrow, and then observe and playtest and fix bugs until Friday. Specifically for the setup, we plan to make sure that we include the volunteers there who work every day to set up the project, to test out our documentation. So we'll be providing these 3 documents to the people at the Wonder Lab. One would be a troubleshooting guide for volunteers, a GitHub repository for our client to maintain the project, and circuit diagrams and a list of models and parts to maintain the physical rocket. And now Courtney will conclude.
So thank you all for listening to our presentation. We would like to extend a special thanks to a few of the people who helped us this semester and made it possible for us to complete this project. We are now ready for questions.
the physical prop really is eye-catching. I don't think I saw what it looks like as as you do more and more of the activities and it builds up more and more. Is it very clear if it's like super built out that I did all the activities and there's not much else to do? I know you let me launch it even with doing 0 activities, but I just am curious, as I do more, does that build out more visually?
So the way that it changes is sort of in relation to these different games that are being played. So it's kind of a set motion right now where there's kind of one change related to each game. So there's a lights change for Mage's game as well as Juan's game. And there's also a change where the top will extend based on Bill's game. And so because it is a small prop that is like intended to be easily replaceable for the volunteers at the Wonder Lab if necessary, it's kind of constrained. So it's only those small changes.
So it's 3 instead of like 12?
Yes.
Okay.
Can you say a little about the production of the physical rocket? It seems like a pretty great prop.
Yes, we would love to. Melanie, would you like to talk about creating the rocket model?
Sure. So I've never done 3D printing for reals. So I made this in Maya, which is not an ideal software to 3D print in. So there was a lot of technical challenges there with getting things to look and fit properly, especially because we did want it to be take-apartable to replace any parts that might break over time or if they want to expand upon it or change any of the colors. So we have kind of created that as a model, and then Courtney went crazy with the electronics.
Yeah, so one of the challenges of this semester is that none of us on our team have like an engineering background. So Melanie worked on the mechanical design of the rocket, and I worked on the Arduino components. And another core thing from the Wonder Lab is that they want kids to be able to understand how things work. So we have all of our electrical components are inside of a clear case so that they can peer inside and kind of see how things are working. And we want to extend another big thank you to Dave Perda because he helped us so much with being able to create this.
Thanks.
It will be placed out of their touch. So they'll be able to see it, but they won't be able to reach it. That is one of the things that we'll be working on during this week in the installation is figuring out the exact placement of these physical components.